Does that work? That works. Okay, that should even be the correct one and all the stuff. Okay. Hi. 3-ish minutes late. So, Flare Spire, thank you for the tier 1 sub and for the 4th month. Okay. Hello, everyone. Let me catch up here. Hello, Commander Keen. First off, hello, Hellencroft. Hello, Commander Keen. Hello, Dutch Black Cat, Spies of Mud, Blackhawk92, Alex Whitney, Malcolm Chesney. You're gonna go ahead and lurk. That's cool. Retro Tech Dan, Tillwolf, and Spies of Mud. Okay. Xerex Perspex. Hello. Okay. Yeah, only 3 minutes. Yeah. So, Kishiru, thank you for the Prime sub and for 2 months. Thank you. Hello, Jot76. So, we have several things to get through today. I was filming the main Imzai video right up until this stream. I was planning on having that video end with kind of me starting this stream, sort of, saying like, I'm gonna get the disk drive working first so I can image everything, and I even have the disk drive open here. So we'll hopefully be getting to that today. We should, because there is a lot of stuff to get to. Cheppy, thank you for the 100 bits, and it looks like we're getting the hype train going, which means cha-chow. There we go. For now, I'm just gonna manually hide and show that, because that works. I was shown StreamerBot as an option for trying to automate that stuff. That is SL Pete Zor. I was trying to get that to be like a channel point reward, but I can't get StreamerBot working or any of the other solutions. So yeah. Hiram, thank you for the gifted sub. Commander Keen, thank you for the 250 bits. Valensteed, enjoy your last day of Pentium Pro. Yeah, we have a fair bit to get to. The video on the IMSA stuff, I'm not sure when that's going to be done. I may have to come in tomorrow and film that. I was hoping to be able to edit it tomorrow, but we'll see how that goes. If I get everything done here, I doubt I'm going to get everything done here super quick and have time to film after, but we'll find out. Fuzzy2K, thank you for the tier 1 sub for the second month in a row. And BS Repelliant, thank you for the 100 bits. Hello, Lady Ironborn. So, you guys want to see the work I've got done on the reforming program? The train keeps on rolling? Yeah. Oh man, what do you bet that the laptop capture is just going to work? Whew, boy, I really don't think so. Let's find out. Oh, it did! Yes! I can't believe it. I didn't even test that before the stream started. Lady Ironborn, thank you for the 1,500 bits. Whoa, thank you. So check this out. This doesn't have GPIB stuff done yet because this is just the first revision of the GUI'd up version. But we can look through here. This is now how simple the code is, kind of simple. But if I exit, put a shit to the background, missing left of the laptop, yeah, that's intentional. Although, let me move this over. Oh, you're missing a bit actually. There we go. So, let me run the program as it is with the demo data, and you'll see this is way better now. So that's what our capacitor reforming program will look like when it's running now. Massively more readable. And the whole log area at the bottom there is automatically going to a text file as well, a CSV. But yeah, this is slightly better, isn't it? Yeah, this took me multiple days to figure out, and it's even better than it seems like, because it's actually fully dynamic. So, oh, ooh, that's interesting. I haven't had that crash yet, and that means that, yeah, because I wasn't doing a thing that I should have been. So STTY space sane, there we go. I'm gonna have to figure out why that crashed, but if we go back to this, I'll just demonstrate in a different way what I was gonna try and demonstrate here. So to add another readout to there, all I have to do is just literally run GUI add readout, and I can rename it to something else like fake here. And I'm just gonna add a bunch of those. Lucy in chat redeemed change keyboard. Okay, we're gonna be changing keyboard, which also means we're gonna be doing a little bit of soldering, but let me just really quick show this first. So if I just duplicate that a bunch and then rerun this, oh, that didn't work, hold on. I need to remove, you can group the readouts as well, which makes this really easy. Boom. Okay. Now we'll do that. And if I run it, you'll see we have a bunch more readouts. And if I zoom out, it dynamically resizes them to all fit. So nothing is hard coded. So if we decide that we want more data, then we can just add it very easily without needing to like recode any of the GUI stuff. So Helen Croft, thank you for the 5 gifted subs. Whoa. Thank you, Cheppy. This is kind of my bag. I joked about this on Twitter, but my last job was actually writing process control monitoring software, and here I am doing the same thing on YouTube now. Well, Twitch here, but eventually this will be a YouTube video. But yeah, so this is coming along very well. I'm extremely happy with that. And yeah, I think we're gonna be able to do some nice, good stuff here. So yeah, okay, I'm gonna have to change keyboard now though, which I wasn't expecting to have to do this early on. I haven't even gone and grabbed the keyboard to switch to yet, because the first thing we're gonna have to do is this. So if I bring the secondary camera down in here, this is my USB PS2 adapter. What does FG do? FG is foreground. So if I really quickly go back to here, what I'm doing is I'm pressing Control Z, and then hold on, let me properly focus on this. Then you'll see right here it says the process Vim was stopped. Control Z pushes the current active program to the background, and then I'm doing FG foreground to bring it back. So that's what I'm doing. If you wanted to, you could actually do something else like watch, dmessage, as a program. Dmessage, okay, let's not do that. Watch ls tmp, whatever, as our program. So that'll automatically rerun every 2 seconds. If you do Control Z here, it'll go back to the background, and then you can bring it back. But another thing you can do is you can run it headless here, and then it runs in the background, and then you can do foreground to bring it to the background. So yeah, some Linux trickery there. But okay, so we're gonna be doing change keyboard in the middle of the hype train. So this here is the GoPro HUD that I try and hide but forgot because I accidentally did that. Okay. Let's see, I accidentally did that to Vim in Linux, but had no idea I could get it back with FG. Ah, yeah. It's one of those things that you definitely would be nice to have like a user manual for, like, when you accidentally press Control Z, it's a cool feature that you should probably learn. So let me go ahead and turn on a light here. So this is a blue, whatever, I forget the actual model name, USB PS2 adapter. And the plastic just kind of left the building at some point. I don't remember exactly what happened. And I think it's got bad solder pads on it. So in order to do change keyboard, I'm actually gonna have to reflow this thing. So let me break out the macro here because I'm gonna have to do that. This is the wrong lens. So see, hello, how's it going? Just got home from work, UK. Hello, Yokai Katana. I don't think I've seen you chat before. It's going well. We are about to try and change out my Keychron K8 for a different keyboard because I need to do that since someone redeemed it. But my USB PS2 adapter is kind of broken, so we're gonna fix that first, and I want to see if we can see what's actually wrong with it. So let's take a look at this. If I bring this up here, I feel like I saw a cracked solder pad or joint. I'm not sure. See, ooh, yeah, some of those look suboptimal to me. The middle right one there, that doesn't look great. DDT 2000, thank you for the tier 1 sub and for the 4th month in a row. Yeah, I think we're gonna make some progress by reflowing that. So let me go ahead and do that, and we will pick out, oh, my tripod leg is folding over, and we'll pick out a keyboard. Yeah, where'd it go? Boom. Whoa, Commander Keen, thank you for gifting 5 subs. Wow. You know, I guess I could show this for every level of the hype train. Because we're now on to level 5. See, I resub at tier 1, but my current sub runs out till tomorrow, so sadly no announcement. Ah, okay. Well, thank you. I still appreciate that. So, okay, let's go ahead and get this soldered. I don't want to use my Gigantor tip. Just use normal one. And putting some leaded solder on here will probably make this last a lot longer anyway. So this will be nice. All right, I'm just gonna quickly go through these pads here. Oop, that shift. There we are. Focus got lost a little. There we go. I'll just get these heated up. Get some good solder on them. No, I don't want to short them. Whoops. Here's a trick. You want to get the solder off? Boom. There you go. Solder off. The Lady Ironborn, thank you for the gifted sub. Go ahead and flow those again there. And I kind of removed all the solder from this rear one. And the last one. There we are. Okay, so that should work now. That's a neat trick. Yeah, it's one of my favorite tricks. It works really well for through-hole stuff too. Like if you're trying to remove a part and you don't have a, let me switch to this camera. If you don't have something like this Soldapult, which is a vacuum solder sucker, and you just need to quickly get solder out of there, heat it up with your iron and then lift the iron off and then just tap it on the workbench. Solder will fly right out of that through-hole. Super easy. But all right, that should do it. I'm gonna quickly visually inspect. Yep, no shorts, so I should be good. Okay, let me, also, Dai Sean, hello, since it's the first time chatting, and Yokai Katana, thank you for the tier 2 subscription for 3 months in advance. Wow. Thank you. Let's see. I don't want to back harder. Don't whack it hard. Oh yeah, if there's inductors or something, yeah. Oh, you know, Cheppy, actually, this is a Soldapult solder sucker, which is kind of hilarious because I was looking through some of my 70s magazines today and I actually found a vintage ad for this thing. But this is the best solder vacuum pump I've ever experienced. It's fantastic. You don't have the action on top, it's on the side, which is much easier. Nice rubber pump that you can quickly and easily run with one hand. It doesn't hurt, and it's so easy to clean. You just pop it open. Oh, it's the best. I highly recommend a Soldapult to anyone. It looks like a Fisher-Price toy, but it's great. So, yeah. Let's see, use that trick while terminating PL 2059s. Ah. Hello, Starhawk, and hello, Tete Consuelos. Yeah, let me go grab a keyboard so we can do the keyboard stuff, and hopefully this time it'll actually work. See, there it is. Ah. Going for a keyboard that's a nice layout. You definitely won't be able to tell what it is by the switches, but it's kind of cool because it's an SGI keyboard. So this is, I'm not really sure what exactly, but we've got an SGI Silicon Graphics keyboard here. Desoldering gun is nice too. Yeah, I really need to get one of those sometime. But there's the pertinent information if I turn off this light, if you want to look it up. So looks like model number is RT6856T. Let's see. Oh, Valiant Steed. Man, why does it keep thinking sucker is a bad word? See, real Soldapults are the best. They absolutely are. But yeah, so we're going to go with this SGI keyboard, which has this really awesome marbled finish. It's really cool. And then we'll take the Keychron and just chuck it out the window, I guess. Which I'm okay with. It's actually so bad I've taken to using it over USB at some points. So, yeah. Let's see if this works. Boop do, and I think we have it. Yes. All right. So there we are. That'll be the keyboard of the day. You just ordered a Soldapult on Amazon? Oh, Bodman, I wish I'd thought of that. I would have had you use my affiliate link. But oh well. Yeah, it is. Well, the keyboard's okay. It feels actually pretty good for being, I'm pretty sure, rubber dome. It certainly sounds like it, but it feels not bad. See, what? You don't have Space Cadet keyboard. What is Space Cadet keyboard? I'm not sure what that is, actually. This is a Goodwill score. This is a grease pen from a Goodwill there. So That's what that is. Actually, I'm thinking about this. Let me turn that light. Oh, that light was already off. Why is this camera so yellow? Let's see. It is rubber dome keyboard. I was looking it up, figure out what SGI machine it was paired with. Okay. Yeah, I was curious about that. See, I only know Space Invaders. Yeah. When most people think space keyboard, they usually think something along the lines of this one. This is more the kind of keyboard that people would think, but now they're going to think Severance when they see this instead. So, meh. But, yeah, that's the most space-like keyboard I'm aware of that I have. That one will never be a change keyboard candidate, by the way. It uses such a weird interface. Space Cadet was used with Lisp machines, and what Emacs was originally developed on. Okay. Okay. All right. But all right, let's see what we're getting at here. So back to the software, which is the main focus of today. If I can, I got to click on the thing here to get that to work. Let's go back to Vim here. So as I mentioned, do not have the gpib stuff integrated into this yet, but I have gone ahead and made pretty basic implementations of the commands for the different pieces of equipment that I'm using here, already wrapped in nice gpib classes to make this a lot easier. So that's happening. Just try and simplify stuff. So we're going to try and integrate that into this code and see how we do. That'll be the first job. And then we'll actually start adding the reforming logic, and then we'll take a look at that floppy drive that I held up a little bit earlier and try and reform some caps on there. So let's see. I used to work at Goodwill. The letters corresponding to the pricing. Yes, I did actually know that, Fuzzy2K, and at some points I'd started to learn what the grease pen marks were to try and see if I picked up something that someone else had ripped a sticker off, if Goodwill tried to rip me off by increasing the price, because I've definitely had that happen. Let's see, I like to look at those artisanal 1975 caps. I want a modern vintage keyboard repros that don't cost $300. Yeah, I've definitely been keeping an eye out on the Dasher key sets that people make. The instant there's one for like less than $100, I'm gonna buy one, and I'll probably like redo my Keychron with them. But yeah, until then, not gonna happen. See, Unicomp did an okay job, but the USB controller issues dealt with make it just so unworth it. The USB controller issues. I haven't had a problem with the USB on the Keychron. I think I might have actually had problems with this adapter I'm now using on Linux, because that one gets a little weird sometimes. But yeah. See, See, I have a copy of Breakfast in America by Supertramp on vinyl that has an eye scratch into the cover of the ballpoint pen. Oh, that sucks. Yeah, I hate when they do it on stuff that it's never going to come off of, like when they put it on labels. That is just agonizing. And it's so hard to clean off of textured plastic. Good grief. Oh, okay. Late Aaronborn. That makes sense. Yeah, that I have one Unicomp keyboard from that era, and it is absolutely terrible. So I wouldn't be surprised if it has USB issues as well. Let's see. I should probably turn off my soldering iron, even though I think it's already auto-offed. But let's see. Are we getting close to test soon? Yes, Torch Nova. We have rewritten code. I will go ahead and run the example again here. I'm going to go ahead and do this in case it crashes. It shouldn't, but just on the off chance. But yeah, there we go. That is the current code for the GUI, so that we can have a really nice printout of everything, as opposed to the horrible nightmare that it was the last time we did this. And it is dynamically resizable, and I can add elements extremely easily in code, so it's a big improvement. Yeah. Grisgore, thank you for the Prime sub and for the 4th month in a row. Oh yeah, I don't think I told you guys. I did get the partner application invite after the last stream, and I've filled it out. So now I'm just waiting to hear back from Twitch on becoming a full Twitch partner. So that's a thing. Let's see. I have, oh man. See, ever seen with a magic eraser? Even with a magic eraser. Oh yeah, so magic erasers are abrasive and they kind of work by removing the top layer. They're not a solvent, which was kind of the thing I try to use for stuff like grease pens, but a magic eraser would probably work, but it can also change the texture of the surface. See, I have 2 one-day prints after redoing the G code. Oh my gosh. Won't be done until tomorrow evening. Wow, that's a long print. So I now have a WASD keyboard special. It's kind of cheaply made. It's unfortunate. Yeah, I don't really do the whole keyboard thing stuff a whole lot. So yeah, I'm barely into all that. So you have an IBM M13 with a Unicomp cable. If you've ever seen Cryosan's 22's video review of the M13, mine is actually literally its twin. Okay. Interesting. Okay. Yeah, I haven't seen that video. I've heard that they're not amazing, that the plastic is inferior, but yeah. Let's see. And thank you everyone for the wishes, well wishes from Making Partner. I'm a little excited. There are some things that'll be beneficial, but some other things that just really aren't going to change. You guys will get guaranteed transcodes in different resolutions, so that's a thing. And we'll be able to rename the emotes to have a more sensible prefix. So I'm looking forward to that for anyone who might actually type those out. But I think that's pretty much it as far as what I'm going to see. Lucy in chat, I am using curses. So if I go over to the GUI code itself here, which by the way, if you look here, that is the GitHub repository for what I am working in, or on here, I should say. You can see I am using the curses library right there, and I've spent a bit of time on trying to get this all working, and I've tried to document it as best as I possibly can. So that was all the really boring, painful part. So I didn't want to do that on stream because it kind of sucks. So yeah, I'm going to use those transcodes on my ThinkPad. So that's sweet. Awesome. So I have a silver badge M and a Unicomp. Unicomp isn't near as bad as people claim. It depends on which era of Unicomp you have, Jan Potts. The one that I built into the industrial gray shell, fantastic. I have no complaints for it. It's my daily driver keyboard on my main editing PC. It's still great and I have no complaints. The Model M, I don't remember what it's called, like the new Model M, the one that's slightly smaller, horrible. It's terrible. Half the keys are breaking. It needs to be bolt modded, and it's not worth bolt modding because it just sucks even though when it's at its best. Yeah, that one's awful. So it really depends. So you have cheap, boring wireless Logitech keyboard. I actually really like some of the older Logitech keyboards. They have a layout for the navigation row, the insert home, end page, delete, take that area. I really like their vertical layout where home and end are next to each other, and then page up and page down are below that, and then they have a giant delete key. It's kind of awesome. So no. The cable is Unicomp. Yeah, real IBM. Yeah. Oh, okay. Interesting. Oh, yours is from last year. Okay. Well, maybe not then. Okay, we got a lot of keyboard chat going on, but I should really get started on this. So I have connected the GPIB stuff to the actual hardware, and I do need to get going on that. So I'm going to get these turned on. I don't know if they're here in chat yet, but the person who bought me the Noctua fans, if you're here, I just want to let you know I did try to get them picked up from the post office today, but I couldn't because I came into here really early so that I could actually start filming the IMSI video, and the post office doesn't open until an hour and a half before I start streaming. And while they were there, there was a pickup slip that meant I would have had to go to the counter and pick them up. They didn't just put them in my PO box, which is really frustrating. They do that so much, it's agonizing. So, yeah, still slightly noisy fan, but we'll be able to make do. All right, I'm gonna have some water. Oh man. Let's see, serial keyboards are cool. Lucy in chat, I'm gonna be doing a serial keyboard sometime on stream here. I just want to get past the reforming stuff, but I'll actually be doing this one. That's a serial keyboard at some point. I've had to make a custom serial USB power cable for it. Yeah, someday we'll get to that. A lot of stuff to get to, but I want to get the this whole thing done with the reforming caps, and then hopefully starting on imaging 8-inch floppy disks, because that's a thing. The USPS try real hard to make things even slower now. Yeah, it's really bad. It's so frustrating. Where's my stool? Oh, that's why I keep trying to find my stool, because it's under the floppy drive. And all right, you know what? Let's just bring up the floppy drive. Okay. So let's switch to this real quick. Talk about what we have going on here. This is the dual 8-inch floppy drive that goes with my CompuPro. Well, one of the two duplicate ones. And this is the thing we're going to be reforming caps on first. And after getting it open here, I can now confirm that it has some bigger caps. They're not that big though in this, it turns out. They're only 4,700 microfarads, but they are 50 volts. So they're going to be barely within the range of this thing. We're not actually going to get up to 50 volts with the current limiting resistor, so that's kind of interesting, but we'll get close enough. That won't be an issue because they shouldn't be running at full voltage anyway. There is one more 15,000 UF capacitor in there that is 16 volts. So we'll be reforming that one as well. Nichicon is good. Yeah, these are probably going to be fine. I have high expectations for these to work, although I think there were some dead Nichicons in the IBM power supplies, which are probably from the same time period. Yeah, if I'm seeing that right, week 25, 1982 on that transformer. So like literally exactly the same time he could have been buying an IBM 5150. So we'll see how that goes. But yeah, I really think we're going to be able to get these working. Now, I'm going to state right up front, no matter what, we're not going to be able to use these floppy drives today. And here's why. This is the interface cable for these floppy drives. Here is the interface cable for normal PC drives, and that's what the CryoFlux interface is with. These are a 50-pin interface floppy drive, and I will have to build or buy an adapter, and I'm actually currently leaning towards buying one because they're not that expensive, because I need to adapt to the SA800 interface. And if we looked through this, actually, we could find the signaling interface here. So page 13. It is actually all the exact same signal lines as like a normal floppy drive, so it won't be a problem. It's just I have to adapt it to work with there. So we'll do that at some point. Like I said, I'm probably gonna buy an adapter, but that means that we can't do it in this stream. We can't connect to this thing no matter what. But we can at least try firing it up, and I'm not sure what we'll see happen, but we can try. So yeah. Yeah, I made my own custom cable hook 8-inch floppy drive into my PC. Yeah. So, mid-wise, most people don't have the actual Shugart SA800 documentation like that. It's just what I got with all the IMSI and CompuPro stuff is kind of ridiculous. So, yeah. But let's see. Didn't you have a higher voltage PSU? Wow. Does the 6624 go up to 100 volts? I'm not sure. The thing I could do is put my 6633 and my 6632 in series to get a higher voltage. So yeah. Is it backed up in the Internet Archive? I'm pretty sure it is a midwise. Most people I've seen online link to a PDF of that exact manual when they're talking about how you create an adapter interface. So it should be backed up already, but I just happen to have a physical copy of it. So I'm not too worried about trying to get a digital one. Look at this fan, by the way. The CompuPro has one of these in it too. This is like the most horrifyingly terrible looking fan I've ever seen. It's kind of crazy, but also super cool looking. I don't know why it has a transformer built in right there. I mean, I guess it probably runs the motor at a lower AC voltage. That would be why, but it's still, whoa. Kind of terrifying. Not as bad as the one that's in the Silent 700 by Texas Instruments, though. It doesn't even have like the 4 prongs around it. It's just sticking straight up and all the blades come out and chop your finger. So yeah, HP 6624, output 20 to 50. Okay, so it's a 50 volt. Yeah. Yeah, Hellencroft, that is exactly the kind of thing I'm probably gonna buy. Yeah. I know I could do it. I could make one. I'm not sure I have a 50-pin interface. But what I want to do is I have just like a kind of short SCSI cable, and most of the eBay adapters. Let's see. Oh my gosh. Let me try and pick this up. This thing is, yeah, somebody mentioned it. This thing is enormous. It's very, very enormous. So, oh man. Gosh. Okay. The floppy drives terminate in a single connector back here, which is pretty standard 50-pin IDC. I want to use a SCSI cable to connect to this and then to one of the adapter boards that are available on eBay that can then be plugged into one of these, because then I can use this with a PC, well, with the CryoFlux. I don't care about connecting this to a PC at all. With the CryoFlux, without making any modifications at all. So that's my main objective. See, yeah, yes, Hellencroft, that is pretty much exactly what I'm looking for right there. That thing. 20 bucks, that's a little more than I would like. But that's fine. I can do that. Wait a minute, where's it shipping from? France? Oh, that's going to take a long time to get. I'm going to shop around. See if there's one in the US. That's a motor coil. By the way, it's a C-frame motor. Interesting. All right. Drop it on your foot. Time for a new foot and a new floor, because to put a hole through the floor and keep on going. Yeah, it's a very substantial unit. It's a whole everything. Yeah. There's so many screws to take off the top too. I mean, look at, that's ridiculous how many screws are holding on to steel. Or is that aluminum? That's aluminum. The aluminum top. Yeah, kind of ridiculous. Also, these motors are hilarious. Has a floppy drive that takes mains power. There's an AC 110 volt motor for spinning the disc. That's it's a whole thing. So yeah, I really don't want to take these out of here or mess with them too much. I probably will have to clean them. Oh yeah, I found something kind of insane in these. Although that's a thing for getting into later, I guess, when the actual video is starting. Oh my gosh, I am like way overheated because I have to turn off the AC when I film in that corner over there, and it makes my hair itchy because I was sweating. So yeah, the AC is finally caught back up, but yeah. See, Adrian Black got the same adapter, I think, so you can remember the Tandy Fix-Up series. I know he has a video where he talked about connecting an 8-inch floppy drive to a PC. I didn't have a chance to watch that. I actually saw Hackaday wrote an article about it too. See, 120V spindle motors are normal for those things. Oh, I figure, yeah, they're normal for an 8-inch drive, but they're not normal for just a floppy drive. So, yeah, that's why it's kind of wild. But I think well, these are actually a Cume model drive, an 842. So these are not the SA800 that this manual is for. The interface will be the same because they'll be wanting to be compatible with this. But I do actually have SA100 drives as well in a different multi-pack like this. So, or in a different paired drive configuration. Where'd they go? Where are they? They should just be out here, I think. Or are they over there? Oh, they're right there. Or is this? Oh, it is this. Let me just take that off real quick. Ugh. Whoop. Power cable hard connected. There we go. SA100 or SA800 Shugart drives. So these are the ones that were more standard defining. These have a lead screw for moving the head, which is hilarious. Oh, they're single-sided too, it looks like. Oh, that's a big deal. Okay. Well, that makes the other ones very nice to have. I did not realize that. This one has some weirder looking capacitors in the power supply. Oh, and there's a finger chopper fan. Yeah, how's that for horrifying? But yeah, here we've got some 4,000 microfarad 50 volt caps. Man, it's like the exact same thing. Then we got a 1,000, no, 10,000 microfarad 15 volt cap right there. So yeah, huh. But same thing, 50 pin cable, connected way down in there. These look like more AC rotation motors. So, but the lead screw with the, I'm guessing, stepper there for driving the head. Yeah. Old linear power supply. I don't know. Lambda, is that like a circuit, a standardized circuit? I don't see a brand. They're blue PCBs, if that indicates a brand to you, because that's slightly unusual for this time period. Yeah, so there's the SA100 or SA800 drives, but now I'm finding that interesting. I'm probably not going to want to use these for disk imaging unless I have to for single-sideds. Had not considered that. That might be a thing, but yeah. So there's those. Oh, they're so heavy. Oh, man. Oh. Okay. But today we're focusing on this and getting those reformed. But that's in a little bit here. First, we got to get stuff set up. So I'm going to grab my stool, which is why I moved the floppy drives, and now I'll put these back on the ground. So you can do single-sided disc in the dual-sided drive with the CryoFlex. Perfect. So just use this then. This one looks much better all around. It has the more traditional linear rails there, the guide rails, and then the steel band for moving the head. So this is like a normal floppy drive, kind of, but it's enormous and is like the biggest cast pop metal body you could ever imagine. But yeah, let me just grab this one and set to the side for right now. While we work on getting the software GPIB integrated. Okay, kind of surprised how filthy these units are. I always thought these old computers were in clean rooms with aircon. All right, you want to see filthy? I'll show you filthy. This is why I'm working on the vacuum cleaning solution. So here's my first example of something that I have cleaned. So this keyboard was actually kept with all the stuff. Can you tell which side I cleaned? Because yeah, that was just vacuum cleaning vacuum and brush cleaning. But that's just one example. Let me show you another one that's a lot more shocking, because I have a direct AB. So here's another keyboard that came with this lot of stuff. And what's really interesting is that that keyboard happens to be the exact same one I got for the Windows XP 20th anniversary video. So you can see the shocking difference between the two and how disgusting that is. Because, yeah. So that's the level of dirty that I'm dealing with. And I will now horrify you by showing you an actual component that is at that level of dirty. Why are you beeping, phone? Here is my spare IMSI front panel. And you can see right there the actual color of the PCB poking through where I've touched it. And then here is a fifth floppy controller. And we can't even tell those are chips. If I lift this up, you can get a better idea of how clean the board should be. But if I just rub my finger right there, we can see that it's really bad. Those are white ceramic chips underneath all that dirt. So, yeah. Everything is like that in this set. So, I'm actually pretty happy with how clean those floppy drives looked inside overall. This is why I'm so focused on the cleaning aspect of this stuff as well. Because it's gonna be really bad. So yeah, that's just a brief tour of how bad it is. The bigger stuff, like the terminals, are way worse. They're so much worse. Oh man. But I'm not gonna bring those over because that's a bigger ordeal to get into. But yeah, just so you can see, the problem is all this stuff was stored outside. Nobody realized what was there for the longest time, for what must have been decades. And yeah, all that was stored outside, which is just kind of crazy to think that there was just Imzai stuff sitting outside in a barn somewhere. Like, usually Arizona's pretty good for not ruining stuff that's stored outside, but all that dust is trying to do its best. So, yeah. How did you get the Imzai and the other one? Craigslist. That's it. So, yeah. But I think it would be correct to say it was literally a barn find. So, I mean, I pulled it out of a structure that had 3 walls, with one of them being the roof. And definitely there's water damage from rain on stuff and some cobwebs and things. So there's actually a dead spider inside of the Imzai. So yeah. Oh boy, yeah, I got a lot of work to do. Oh man, let me catch up here. See, all this dirty picture streaming speed restricted. But yeah, so it's not looking great. Yeah, poor spider. We got some really rude spiders, I'll say, in Arizona. So I'm not gonna shed too many tears. So all right, let's get back to the stream. Yeah, let's get back to the main task here with the software. So I wish I'd known about my school closing down. When I had money, I had to purchase a few of their IBM NetVistas. Oh man, rusted stuck to the floor because of overflow zealous floor cleaning. Whoa, that's really bad. But all right, let's see here. I am going to not make any changes to the GUI code. So let's close that. So the first thing I want to do is let's activate the PSU code here. So the PSU is actually 12. Let's change that. I had these backwards. And that should work. We'll see if it does. No. Oh no. STTY scene. I'd mistyped that on here, but the actual error, line 10 in init gpib interface ID is not defined. Okay, so let's go back. Just run that. Okay. FG. Let's see. Move. Yeah, that'll be good. Okay. So I need to go to the power supply code here. And gpib interface. Okay, so I just need to get rid of that. Minor mistake. Perfect. Okay. So right now I'm feeding random data into the power supply voltage and oh, actually, is that working? Oh yeah. So right here it's random data. So what I'm going to do instead is I'm going to read the data from the power supply. So let's do PSU dot get volt, and then I should be able to just go down here. Psu get current, and that should nicely wrap up all of the gpib commands. What's STTY saying? So when curses crashes in Python, it crashes poorly, and the curses stuff that lets all the terminal manipulation happen makes it so that new characters aren't printed consistently. So STTY sane just resets all of the terminal settings to be normal, so it doesn't break it. Let's see, what do you program? I'm programming in Python here, but I am writing a program that will allow me to interface with this test equipment here, which will be used to take capacitors, which, you know, these, and rebuild the chemical insides to work better without needing to buy replacements, because I don't want to have to buy replacements for all of the vintage hardware I've got. Okay, line 28, get PSU volts, type get volt, take 0 positional arguments, but one was given. Oh, I forgot to put self in all the stuff. Does the reset command do the same? I don't know. That's an interesting question. Let's try that. Okay, so here it is, crash, and if I type ls, you'll see that the characters don't actually show up, and then when I hit enter, they're all spaced weird. So reset, boom, ls. That does actually work. Well, that's kind of cool. Well, that's really good to know. Okay, so I need to add self to all of these because it's a class, and I forgot to. Python is super weird in that it passes. It's like a functional language that barely has object-oriented, or procedural language, I should say. It's like a procedural language that barely has object-oriented stuff implemented. So you have to pass the object as itself into all of the fields of the class. So yeah, works and clears the screen of crash junk. Well, I want to see the crash errors, so I don't necessarily want to clear it, so I'm probably going to keep using STTY sane. Let's see, name device is not defined. Oh, now I need to do self.device because yeah, it's like that, self.device. Let's just do that. Oh, hold on. The multimeter is probably going to have the exact same issues, so we'll take care of all that first. And bingo, but it's not very happy. Why is it not happy? That's weird. It's not. Oh, that's strange. Run it twice. Name error, device is not defined. Get, what? FG. It's, oh, okay. I gotta put it here too. So, whoops. Self. There we are. Let's see. Although you should be able to use the term iOS tc get attribute, store the original terminal settings, and then restore them on cleanup. Foobar, yeah, probably I could manually redo everything. I'm not super concerned about it. Line 27, ooh, good catch, Commander Keen. Self. All right, there we go. Is there supposed to be a space in self value? I don't think it needs that. There we go. Those are accurate readings to the power supply. If I bring the camera in there and turn the light on, you can see those are correct. So we're getting actual readings from the power supply now. So that's nice. Go ahead and get the light tightened back up there. Let's see, and line 14 too. Did I miss one? Oh, I just backgrounded that. Let's see. 14. Ooh, good catch. Get output. I'm not actually sure. Does that work? I think it does, but yeah. Let's do self dot. There. Okay. That all now looks right. Okay. Minus 2,000 volts seems legit. Well, when it was running the GPIB, or the power supply stuff, you can see, oh man, what is the problem here? There's something, line 31. I think, oh no, it didn't. Why did it crash? But anyway, voltage here, 0.04 volts, that's what the display shows, and then negative, 100 microamps is what the display is showing over there too, so yeah. Minus 0 kilovolts, well that's because so everything else is getting fed literally random values. So you can see right here, rand int, nothing is a real value right now. But I am doing some of the calculations here, so like, I'm calculating the V drop on the resistor, and I'm calculating the capacitor voltage by taking the power supply voltage and reducing the that by the voltage drop across the current limiting resistor. So yeah, it showed a GPIB error there. Yeah, that was what was weird. But it did it when I scrolled. File 28, return get volts, in line get volts, return float. Wait a minute, why, how? Device name. Line 28, did I not save? Is that what happened, or did it use like an old one? Because these are all self. Return, float, self, return, float, self, return, float, self. So those should all be good. I don't know. Here's what I'll do. I will rewrite that. I'm gonna rerun it, and I'm gonna try zooming in. There we go. PSU get current, line 31, PSU get current file, self, right, oh my gosh, all the stuff is mixed up. A reader write has been aborted possibly due to a timeout or reception of device clear command. It seems like it only happens when I scroll. Oh, now there, yeah, that's super weird. I think the problem is when the table goes off screen, something happens. So like if I run it now, it won't work. It won't work. Yeah, here we go. So it has to be able to fit the whole table. Okay, well that's a minor issue. I don't consider that too big of a problem. I can fix that later if I really care. I think it's just happening because it's showing a GPIB error because it's crashing in the middle of that. Ncurse is taking too much time to redraw the screen. I think it might be taking too much time when it goes out and then crashes. That might be it. So I think as long as I don't zoom in, it's fine. So I'm gonna not worry about that for right now. But okay, let's bring the multimeter into this, but first I gotta fix the multimeter to add all the stupid Python object-oriented self things. Although it almost looks like I actually did all that here. Oh, almost. There are some that aren't. Self dot. Self dot. Put the GPIB stuff in a separate thread. I could, but the program is going to crash no matter what, so I don't really think it matters. Okay. Ncurses, yeah, like Doctor said, don't do that. Yeah, that's for Pete Zero or Pete Zor. That's what I'm going to do. I'm just going to not scroll in that much. I wonder if I could set a minimum window width. That might work too. Okay, I think that's all of the device calls wrapped with self. Yeah, I think all that's good. So I'm going to come back over here and I'm going to enable the multimeter. And then I'm going to configure the multimeter, DMM dot set current And I'm going to set the range, or the max value to, like, I don't know, 1 amp. And then the resolution to 0.000 milliamps, 0.001 microamps. And now I'm thinking I should maybe set this to, like, 100 milliamps, or maybe 10 milliamps. Because I'm getting into the actual ability for that to do stuff there. And then what I'm going to do down here is the readout for the multimeter is in microamps. So when I update the readout from the multimeter, it's going to be in scientific notation, and it's going to be at amps. So if I multiply it by 1,000, then it'll be milliamps. But if I multiply it by 1,000,000, then it will be in microamps. So let's do that. Right. And let's go ahead and try it. I assume it's going to crash. DMM line 10 in it. GPIB. Oh, yeah, the same error the other one had initially. That's a copy-paste error. Boom. Okay. Now it's configured the multimeter. Line 21, get PSU volts. Ooh, that's interesting. Hold on. Could not convert value from string. Device read. Oh, whoa, what? Return PSU, get volt. That's weird. Line 68. Device read returned an empty string. Ah, well, that's complicated. The power supply did show an error as well for some reason. Why did it error? That's going to be difficult to fix. So what happens if I just rerun it? Strange. Okay. All right, the multimeter is not yet reading actual data from the multimeter. Let's go do that. So we will do dmm.read. Bingo. Oh, it's perfect. Oh, it's so good. All right, if we take a look at the display of the 34401A, you'll see on the display it's in milliamps, but then it's down by 100 for microamps, and I've multiplied. It really hates it when I zoom. If I run it again here, you'll see that the microamps showing up there match the milliamps perfectly, so I'm very happy with that. So it might be worth checking for that so the program doesn't randomly crash while reforming if there's GPIB hiccup. Yeah, I should do that. I'm going to have to do... I might wrap all of the reads in try-catches, or maybe I'll wrap the floats, the float conversions in try-catches, or... let's see. Maybe I could do a while loop that is while the string read back is not empty. Yeah. DMM in the current list is still scientific. Yeah, I wasn't sure if I wanted to convert that or not. So I was kind of leaving that. Because do we want to change the data that's logged like that? Or should we go ahead and float, wrap it, and then do that? Because we're reading as a float. So we're getting that. I could just move the times 1,000,000 to the readout. So if I do this and then just put it up here. Paste. Now everything will be converted. Maybe that's a better way. Yeah, maybe we should just do that. 'Til Wolf hotkey for change to scientific. I do actually want to add some command keys, but I'm putting that off for later stuff. Like I would be able to hit spacebar to pause it and turn off the output voltage in the middle of a reform test in case I need to like adjust cables or something so it doesn't like read bad data, because I think that would be super handy. I kind of wish I had put all the LED stuff away because it'd be really, well, I guess I can just hook up the battery again, or the one capacitor here. See what it does. I put all of the, oh, you can't even see me talking because I left it on that. Oops. Let's do this. So, all right, I'm gonna leave that for a moment. We're gonna go hook up the capacitor here. So I got my leads and clips and stuff. Let's do this. So power coming from here. Boom. I'm gonna plug these, that's backwards. Plug these back into the breadboard. Grab that 220 ohm. I feel like the 220 is a pretty good compromise between actual current limiting and maintaining a higher voltage. So I'm going to keep using that one. Put that on the high side. It's also nice, it's all such low power that I don't have to worry about using a breadboard for setting stuff up because it'll just be fine. All right, there's that. And these will be the actual power connection to the capacitor. Also, I should clip the sense wires onto here. Oh, it's going to really limit me how far away I can get. It doesn't matter. Whatever. Sense is useless. Just make sure they're not touching. It'll be fine. Okay. Ooh, yeah. So we're actually changing something this time, now that I think about it. We're going to be hooking up the multimeter with current. So I have this little weird probe thing that I've made. This plugs in high side, low side, and then the breadboard's going to have to go right in front of this, but it will work. So this will go to ground. This will go to the resistor. And that is our actual connection. That we can then plug our capacitor into with. So high side, low side, sort of. Come on, there we go. So that is minus, that is plus. I'm going to go to local control here. That's right, this is going to constantly keep resetting. I'm going to can that. I'm going to go local control, VSet. I'm going to go 5 volts, enter, iSet. Let's go with 0.01, enter. And is there no current going through this? Why? Is it just charged already? Is that why? What if I short? Boom. Why do I not get a current measurement on the 34401A? Oh, because it's on remote. Hold on. Boom. Boom. local shift DCI. Bingo. Okay. So that'll work. I can see it's barely drawn anything. Take that off. Discharge the cap. Plug this in. It should briefly show. Yep. And then it drops down. Perfect. Okay. So that'll give us data. But now we're going to have to code in the actual voltage increase. So, all right. I didn't check which capacitor is that. Oh, that's the one we haven't reformed. It's probably still good, so it doesn't really matter. Definitely more complicated than my reforming setup for high voltage caps. This is fairly complicated. I won't disagree with that. But the idea is that I will just set up something like this breadboard thing, although I'll probably make a cable that's got the wire integrated. I'll probably make a harness where it'll end in both banana jacks and the clips, and then I'll be able to just clip onto the capacitor and be done with it. So and then the program will run, I'll set the voltage, and then that's it. So, let's see, magic smoke today? Why do we all think we're gonna magic smoke stuff? Is it because I was shorting the output of the power supply? It should be fine. It's current limited. It's not gonna melt the screwdriver. So let's see, I am getting data, 5 volts, which is correct. Getting like no current flowing. Okay, I'll bring up the capture again so you can see that. Let's see, man, you guys are... No, caps will be fine. Yes, let the smoke out. I'm not... No, oh, are you asking me to blow one? Because I'm not going to intentionally blow one, period. That's not happening. Ventilation's so poor in this office, I'm not releasing that toxic fume into here. So that's not happening. Unintentionally, I can't guarantee. I'm pretty sure it's not going to happen, though. So, okay. I think we have all that done. So now we need to add in the logic that we were kind of using last time to figure out what to change the power supply voltages to. So I'm going to shrink this down a bit here, and let's look at that. So, great. All right, so we calculate the resistance. We are calculating the resistance. It's kind of meaningless because we don't actually have current flowing in because it's not changing. So there's all that. Got to get to that 100K channel point somehow. Well, if you watch long enough, you'll get it. That's definitely a thing. It's meant to be something that is difficult to attain because you're going to throw me off of whatever the next stream was going to be completely. And then I want it to be highly rewarding to where you'll get to like have all the questions answered about one of my computers that maybe I didn't answer in the video about it. So. Okay. Okay, so I haven't yet set a capacitor maximum value, so I should do that. Pordizo, thank you for the tier 1 sub and for the 4th month in a row. Gonna get to 100K by the end of the year? I can tell you it doesn't take that long. I don't know if you all know this, but also you get more points when you're subbed because you get a multiplier. Not that I'm gonna try and hold that as like a thing to force you to sub, but just FYI. So okay, I'm gonna go here. I'm gonna change this to cap, and I'm gonna put this as I max. And because we're in microamps for everything, I'm going to specify this as microamps. So we're going to set this to 2,000 microamps. That's our goal, to keep it at that. And I'm gonna comment this, calculate next jump to 2 milliamps. All right, and then paste. I'm going to set a threshold. So I min, and we'll put that at 200 microamps for now. You're at 16,500. Well, that reminds me, actually. So I'm currently setting this up for the method that will do current measurement with the 34401A because it's going to be really well suited to that. But we could actually use the blackness. No, the HP 16500C that is not at all visible over there. My flashlight's not on me. It's my logic analyzer oscilloscope thing, but it could be used to do voltage measurements at the same time. So I could theoretically have that as a third piece of gear over there doing voltage measurements on the cap so that we could get that data as well. The only problem is that it is way more complicated to interface with over SCPI because you have to connect to not only the instrument itself, but then you have to tell it, I want to use this card in this configuration with these parameters set up in this way, and it's a way more complicated thing. See, don't forget to take the resistance of the DMM into account. Isn't it barely noticeable? It's going to be like a 0.1 ohm shunt or something, maybe even a 0.01 shunt. I can measure it with my fluke. Where's that at? I don't think it's going to be significant. I'm not even sure my fluke will be able to measure it because it's going to be so low. I would need the 34401A and 4-wire mode to measure that resistor, really. For low current, it could be around 100 ohms. Oh, man, okay. Well, this might reveal that. Okay. Let's see. So, touch probes together. We get that. Put them in here. It's like 5 ohms-ish. Maybe. I guess that's something. And it's showing a microamp on the meter, so it's not that much power. It's not showing a microamp. One moment. Because it was locked from being in remote mode. Let's see how much actual power it's putting through. So it's 1 milliamp, which is in the range. Okay. So it's about 5 amp, or 5 ohms. That's within the margin of error of the tolerance of the resistor, I would say. So I'm gonna not worry about that. Now my cables all came undone. Okay. Go back to this. All right. See, 5 ohm compared to the 218 is 2%. Yeah. Well, this is not necessarily the same resistor. But yeah, 2%. It's not that much. Okay, so we have Imax and Imin. All right. And we will have cap. Well, we're going to have power supply I, not cap I, which is fine. Actually, it'll be DMM I we'll be using to compare against. So let's start adding the logic here. Okay, so here is where we will be doing calculate, actually check for min, current, and calc voltage jump. Okay. So if DMM I did this like really ridiculous like Python dict to hold all the data in. I'm not saying this is the best way to do this, but I had to track so many weird variables and I felt like this was not a bad way of doing it. It seems fairly descriptive, but it's kind of awful still. I'm not super thrilled with it. I'm tempted to make it so that the objects that I wrapped the gpib commands in hold data for like one cycle of the code. So it doesn't have to, like every time I reference the voltage or the current from something, it doesn't have to re-get it over gpib. But then I would have to add like an update command into this, and like, I don't know. So I haven't decided how I want to do that yet. But let's see this. If that is less than d cap I min, more lines, it has to be better, right? Yeah. Okay, so if the current through the multimeter is less than our minimum step, then we're going to calculate the next target voltage and we're going to set the power supply to that. So that will be VO, yeah, cap voltage, So that's something. We haven't added, we're actually going to add a readout, so that's really handy here, because I didn't think about this. Ooh, how do I want to do this? Maybe a calc object. Calc, all right. And then I'm going to have a target voltage. I think I'm going to put that, whoa, what'd I do? I think I want that before the multimeter, so. Target voltage V, and it's in its own group. This will be DMM calc. VID, that's fine. Okay, then yeah, well, that's fine, whatever. The calc V equals, and it will be, you calculate cap voltage, I can just copy it from up here. Cap voltage plus the cap I underscore max times the limit resistor times d r underscore limit r. Okay, I think that'll work. And I will update the reading of that, which is calc VID and then calc V. Actually, I should set calc V to 0 first up here. So it doesn't error. Okay, I think that will work. Let's just run it. Boom. Target voltage. Ah, cool. We're going to set it to 44,000 volts. Perfect. I know exactly what's wrong. We've multiplied the current by 1 million so we can get it into the nice readable range. So I'm going to have to divide it by 1 million to do the math. Or, oh, I was in microamps here, so I'm actually going to have to do... you know what? Screw it. Let's just... Or where am I at? DMMI. Okay, so... Actually, if I just divide this... Hold on, IMAX. No, I think I actually... No, I have to divide this by 1 million. The capital reform fast, yeah. We're going to divide this by 1 million. Divide, 1, 2, 3, 1, 2, 3, boom. Sam prediction's not so crazy. If that power supply can hit that, then, yeah. Okay. I think that's going to be more correct there. We're at, like, 0. So, although those numbers are bouncing up a whole lot. What is going on? Something doesn't seem right. Power supply current is currently negative, which is really throwing off everything. So, that's not helping. All right, well, here's the thing. The power supply is going to be capped at 10 milliamps, all right? It cannot go higher than the rated voltage of this capacitor. So, no matter what, it shouldn't have an issue. So, it really can't be a problem. Matter of fact, I'm going to come up here and do psu.set current. All right. I'm going to set it to 0.01. All right, 10 milliamps. I'm actually going to set the voltage to psu set volts to 1, just to test if that actually works. Boom. It did not. It errored. Why? Has no set volts. Oh, because I've been doing it as singular. That's why. Boom. Bingo. It beeped. Why did it beep? Both of them beeped. Ugh. I don't like that. Why did it error? Set volt. Is the voltage configuration thing wrong? PSU set volt V out plus string value. Yeah, so that should be good. Let me look at the old one. Yeah, it's only a few hundred volts now. Something's still not quite right there, it seems. Why is the cap voltage so high? That's not right. The cap voltage is being calculated from V drop, which is using DMM current here. So that needs to be divided by 1 million. Divide by 1 million. 1, 2, 3. 1, 2, 3. Okay. That should fix your 100,000 volts. There we go. Target voltage 5.44. Happy? There we go. I found it. You're going to use a diode on the output. I've missed some of the stream. I shouldn't need a diode, Savick. I have a current limiting resistor instead. So make sure the current variable can't go below 0. Yeah, I suppose that makes sense. Since I am controlling it, I might as well. If, well, actually, I equals if I greater than 0, return I, else return 0. There we go. What if the cap is discharging back into the supply? Maybe the negative supply current is real. I'm pretty sure it's just an error in the readout. I'm not worried about the power supplies reading for current because it's not real. It's terrible. So negative current is annoying due to during debugging calculation. Yeah. So, but that should work. I don't know why it's not setting to 1 here. So LCL error 11. Maybe look up the manual supply. May have inverse current protection. Actually, here's something that I need to figure out. I think this power supply can source current, but I think you can also sync it. I need to figure out if I can use this as a load tester, because I would really like to load test the power supply in the, in the floppy drives before I turn it on, but I don't actually know if I can. So that's a thing. Yeah. But I think it can sync current too, because the manual sound is kind of confusing, but I think it can. Okay, local control, clear entry. Okay, I'm gonna let it run again, see if it errors. You can sync, but that is not controllable. Ah, that sucks. That's really annoying. Okay, it still didn't set a voltage. Okay, local error. Okay, it's error 11. I'm gonna have to look up what error 11 is, and I don't think I'm stream clear over here. I am not. It is weird. Let's do code. That way I can quickly get to there myself. And then I'm also gonna do this. Oh, that's a weird way of showing that. Okay. So you can only set a negative current limit for the syncing. Getting electronic load would probably be better. Yeah, they're just expensive and they suck. They're like 10 watts or something. To get them that are like really good, they're multiple hundreds of dollars. So it's, yeah, if I could use this, I would prefer that. Okay, I can now go back to this, and I just remembered I did not eat lunch, and I hate eating on stream, but I'm gonna have to do that because it's only gonna get worse. So I'm having leftover frozen pizza. So exciting. Yay. Mmm. Delicious. Okay, what is error 11? Because that's what, we look at this, checking the error from trying to set the voltage, and it's showing error. I can't see squat. That LCD sucks. It's showing error 11, and I don't know why. So I need to figure out what that is. String of alpha characters was received but not found in the table of valid commands. Okay, that's weird. Don't start chugging Mountain Dew, we're gonna have to report you. Guarantee that won't happen because I don't drink sugar soda. So, not a problem. Alright, let's look at what it's sending for the command. Set output, out 1, set volt. Okay, V out. Oh, I have 2 spaces there. Is that the problem? Is it because I put 2 spaces? Oh no, poor baby power supply can't handle 2 spaces. No, I don't think that was it. Error, local, error, oh, end the program, local, error, 11, okay, clear, rerun it. No, that wasn't it. Okay, local, error, it's still 11, okay. If only I could show what the command is. Nice try though, yeah. That would have been nice. Let's see, I'm going to copy that. Now I'm going to print, paste. Let's just see what it's setting it to. Boom. No beep that time. V out space 1. How is that wrong? What? Unrecognized header. String of alpha characters was received but not found in the table of valid commands. How? That's absolutely correct. Those quote marks, they're not showing up in the output though. Maybe too many decimal characters for the value? 1? Because it's not doing it though. Diet Mountain Dew exists. I generally try not to replace sugar soda with just diet soda because that is diet soda's not great for you either, and I figured if I'm trying to do healthy stuff, I should not just go from one bad thing to another bad thing. So the most exotic thing I really drink is, well, actually coffee, but if I'm gonna have like a flavorful thing, I'll have a lightly flavored sparkling water like a LaCroix or bubbly or whatever. But yeah, generally not diet soda. You know, I got a dumb idea. Float that. Float. Maybe it needs more precision. Still errored. It was V out 1.0. Let's go back to the manual. V out space number sets the output voltage on the PSU. Okay. Back to the code. Over in the original code, let's look at that. Not set amps, that's actually kind of useless. Do vset space number, okay. Down here, PSU write vset space string, what? Oh my gosh, it's right, it's vset, not v out. I hate the interface language on here. It's so confusing. That is twice now I've made that problem. Why can't it just be V out? Ah! Okay, there we go. I did the exact same thing before. You are correct. 100% right. I did that before. It just doesn't make sense that vset is a thing. I don't understand. Or the set commands in general. It's set to 1 volt. There we go. Something beeped. I don't know why. Gosh. Remind me to explain to you sometime just how much bull there is in aspartame study. All artificial sweeteners are bad. Thing is essentially founded entirely on it's complete garbage. Literal textbook examples, bad science. Not doing that in streams was very much rant copy material. I'll put it this way. I can taste when I drink something like Diet Coke that it's just not like a natural food product. It is not good for you. You can just tell. It's not right. To enjoy the stream, he's instantly doing the same mistake he made last time I left the stream. That is great, Just Pika. At least I learned, well, I don't know if I learned quicker this time, but at least I know, yeah. Is beep command? It is not, no. The beep command is not in here. On both of these, I'm going to go to error. I'm going to clear that. I'm actually just going to turn the power supply off and on again. Okay. Now let's run it. Nothing beeped. Perfect. We're there. Okay. Excellent. I'm going to do calc vmax as a thing. Calc v underscore max. And while true is going to be the PSU V is less than the calc V underscore max, and that will be our limit. The diabetic loved me that Splenda taste. I really didn't like Splenda. I understand that, Starhawk. It's just, I don't know. I don't know quite how to put it. Like, I know this pizza is really heavily processed garbage food as well. It's just something about diet soda really doesn't sit right with me. Okay, we are officially doing voltage changes on the capacitor. Although, now I think about it, what did I set the max voltage to? I set it to 0. That's not going to do a whole lot. Let's set it to 10. And we're going to set our maximum jump to 1 milliamp. Let's see how that goes. Right. Okay, let's run this, see what happens. Should actually do some stuff. What did I set the target voltage to? I think it's going way high. Oh, maybe I set it to 10? Is that it? Season B, I can't. There's a 200 volt cap, it's a 50 volt power supply. Well, that'll look good. Let's set our jump higher. Let's set it to 4 milliamps. It's still not right. Oh, it could be because I didn't short it. You know what? The output's not being set back to 0. Let me do that. I don't want to blow up capacitors. I really do not. It will just hang around me. The ventilation in here is terrible. Okay, well now, whoops, turn off the power supply when it is finished. So, can the window behind you be open? No. It's just solid panes of glass. They don't move. Boom. Okay, well that didn't work because it's not even connected. So that's kind of hilarious, but all right, here we go. I'm plugging it in. Outputs are 0. Boom. Run. That's the wrong thing to run. Current is not jumping up much at all. Any window could be open if you have an anvil. I mean, yeah. I am going to set it to log the target voltage because I want to see it not change. So let me add that. I think that'll do it. Okay, so that changed like real quick. Something magical about being so close to popping caps, but and having the will not to do it. It's pretty easy. I don't want to breathe capacitors. This cap's trash as far as I'm concerned, but I'm still not going to blow it up. I mean, I can't because it's 200 volts, but yeah. What am I doing here? I want to... I feel like it's not reaching Imax. It's just not even getting close. I don't know if it's because it's charged already or what. Swap the wires to deform it so you can reform it after that. Yeah, okay. So what happens if I do this? Current. It's almost like the multimeter is not actually reading current. How do you initialize the DMM? I am setting it with a max of 10 milliamps and a minimum of 1 microamp. I don't actually know what the range is, so that's a thing, but on the DMM itself, it is in milliamps and it's showing at precision of 1 microamp, so that kind of matches what I set it to. So, AC or DC? DC. You can see ADC there. So it's DC current. I agree. It does seem like it's not reading quite right. Although, actually, when I did the test with the screwdriver, it was showing some real current there. So if I short that, Control Z, boom, Control Z, boom, error. I was like, because I'm gonna zoom out a little bit. It's like it's current limiting. What gives? Could my breadboard connections be bad? It's not even getting like power to this. That could be a thing. Is math wrong for lower than 1 milliamp? I don't think so. I'm actually guessing now that maybe I'm not making good contact. Because it would look like if I unplug the stuff, it looks exactly the same. So maybe it's not actually working. Let's change out how I have this connected to make sure it's actually functional. Is it set to use rear terminals? No, I think the breadboard cable thing here I made just isn't working right. So I can plug negative side into this and then have these be the actual connection. Progress or not, I'm just glad to get that slick UI made for it. I'm very happy with the UI. It came out really nice. Supposed to have in here. All right, I'm going to show you guys another trick. So here's how to have the camera die. Because oh my gosh, are you kidding me? I just completely trashed that micro HDMI adapter. They're getting really annoying with these things. It just crunched over. Hopefully the cable died and not the GoPro again. Oh my God. There's another one over here somewhere. Good grief. But it just crunched and then gone. It's very frustrating. It's strain relieved even. It's supposed to not be possible for that to happen. I'm gonna add more length on this end, I guess. And now it probably won't come back, will it? Because this USB adapter things are terrible. It's going to really be a problem if I lose that camera for this stream. Okay, good. Mr. Happy 404, thank you for the, whoa, tier 1 sub for 6 months in advance. Wow, I really appreciate that. That will help a lot. Thank you. Okay. All right, so here's the trick. You have a breadboard, you want to connect a clip to it, all right, gator clip. It's kind of a pain to do that. Here's what you do. Anytime you trim a resistor leg like this, you save it, you put it in some thin pliers, and then just bend it around. You now have a 2-prong connection, kind of like a staple. You could use a staple actually, but you can put this into the breadboard, and you now have a really solid way of connecting clips to a breadboard. So just do that, and you got like the easiest way ever, connect stuff to a breadboard with clips. Oh, these GoPros are really annoying. Yeah, I'm really annoyed about that cable dying. Oh well. All right, so I'm gonna plug that in there, and that is now. Actually, this needs to be here. That's not how ground is connected. And actually, I think I can just move this over here, and now the clips that are going to the capacitor itself can be over there. And maybe we'll actually get some real readings now. Malcolm Chesney, great to see Shelby eating no egg, do multi-hour stream standing with only water. It's pretty rough. I will say, I really don't want to eat on stream. But these streams do get kind of difficult without taking like breaks or anything. So I will say, it's probably going to be a lot nicer stream for me having done this late. Usually I eat something like this right before the stream starts and then just hope it holds me. Actual readings! Whoa! That was amazing. That was perfect. I couldn't be happier with that result. Like, I instinctively want to scroll up through the history of this, but I can't do that. But I am logging the data, so what we can do is we can just open this. What did you do differently here, Cody? I used cables that weren't bad. There are no software changes. All right, so we're saving a CSV, and I can just open this in LibreOffice. So we can see here at the beginning, all right, it's quickly taking in current because this capacitor is probably fine. But then we get to a point here where we jump up, and then the current going into the capacitor increases and then very slowly decreases as the capacitor probably does reform. And then here it gets below the threshold. It determines a new target voltage to use, and then it bumps it up to that as the main voltage over here on the power supply. And then we can see that the current goes up again. That is awesome. What were we calculating the step up to be? Let's take a look at that. I don't want to run it again. We were trying to set the next value to 4 milliamps. We weren't getting anywhere close to that. Really? DMM current. We start out at 2 there. It's only jumping up to 600. Like 700. What gives? Yeah, 688 microamps. What? That doesn't make sense. Ooh, you know what? I have a new thing to add. So here's something. Well, first off, Wesley Nixon, thank you for the 100 bits. Saw that background on your vertical screen. I thought it was cracked. Oh yeah. You may have seen the line there on the right. That's a setting I have in my vimrc file to make a line on column 80, so I can visually see. It's not super distracting because it's dark like the background, but it is visible. What was I going to do here? Oh yeah, I was going to show you this. So I added a SIGINT handler in this code right here. This allows me to press Control-C and not have curses die in a dumb way where the STTY stuff has to be reset. And I forgot I added this line, add PSU output disable to this for when I do Control C's. So I forgot to actually do this now that I have the power supply stuff added. So I need to do this. So when I Control C, it works. So, and all this programming without programmer socks. I don't know what programmer socks are, but I am wearing socks. So there we go. All right, we rerun this. Current does not jump up as high as I would like. Okay. I won't look that up right now. I do want to figure out why this isn't going so high on current. It could be that the capacitor just won't pull that much current, I guess. Just curious, how'd you learn programming? 2 ways. Myself, which I started first, and then I actually went and got a degree in it. So it's both things. My degree, I mostly focused on C and C++ because I wanted to be a real programmer. And I do actually still prefer C and C++. But for something like this, Python makes it a lot easier to develop something over an evolving period of time. I wouldn't be too surprised if I go back and recreate this in C++ or something like that. But on the other hand, the idea is that I can then distribute this to people who could then modify it for their own test equipment or something like that. And being Python will be a lot easier for that because you don't have to deal with compiling dependencies. And yeah, I do have an associate's degree in programming. It's not that fancy, but I do have a degree. So. Yeah, that's what I'm thinking, that it may just not be able to take in enough current to reach the maximum. So what I'm going to do is I'm going to set this to 10 milliamps, let it just do full power, and see what happens. See how high it goes. Okay, we got an 800, 878. I'm wondering, though, if it's... Could it be spiking up to that between readings and then just pulling in the current so quickly? But a resistor and current, I like that idea. Let's simulate a bad one. I'll put a 1K resistor in there. Going to be a little tricky, but I think I can do it here. So I'm going to just try and cram the legs right there. Or you know what, I could just go put it on the breadboard, couldn't I? Well, that's there now. All right, let's go back to this. Rerun. Ah, there we go. It went to 2 and then stepped it down. So it's only going at 800 microamps. Yeah, on that Savic, I was actually thinking about putting like a 1 mega ohm resistor on the cap. Needs more current now. It's set to be able to jump up to 10 milliamps. There's nothing limiting it to 800 microamps right now. The power supply is set to 10 milliamps. The code is set to let it reach 10 milliamps. I don't know why it's stopping at that. Target voltage equals 0. That's because it hasn't updated yet. It's waiting for the current to drop down enough. I guess I could set a higher initial voltage. So instead of volt being 1, I can set it to 5, and we can see what happens. Ah, there's some real current pull. Okay, so at 5 volts, we're getting 4 milliamps. Yeah, Tillwolf, I think we're getting there. I'm starting to run through in my mind, is there any reason that we couldn't run this on one of the Nichicon caps in the CompuPro floppy thing? Is there any reason at all? Because I can't think of one. Cap resistance seems too low now. There's a 1K resistor. There is a 1K resistor in there. Yep. I can pull it out while it's running. You can see it. Boom. There it goes. Now it's going to go ahead and finish. Bingo. Rerun it with it attached. See, it starts out at 10 milliamps, and then it slowly bumps up the voltage. Yeah, Ben Mad Dog. That's an interesting thing. The resistance should be higher over there, shouldn't it? Why is that wrong? Oh, you know what? Is that being calculated from the DMM current? Because that's wrong. Yep, right there. Okay, so let me fix that. Boom, boom. I'm not sure that multiplying it into microamps at the beginning was the right choice, because it seems like I have to counteract that a whole lot. Okay, boom. Did I actually? There we go. So it's reading at 9. It's reading at 1K. So, yeah. I'm also seeing a potential issue here in that I might want to substring a limit on those numerical values, because they are literally hitting the edge of the display, the DMM current right here. If that was 1 character more, it would crash the program. Yeah, the resistance measurement's working now. So, do you get sane resistance reading with the... Let's do it. It's bouncing all over. So 73K ohms, that's probably not too far off. Yeah, resistance, it's 1709, 30,000, 5500. The current is bouncing up and down, so it's changing that reading. So, yeah, I think it's working. So... Oh man, all right. Are we gonna do this? Are we gonna reform a cap in the power supply? Yeah, limit all displayed values to 3 decimal places. Yeah. Right now I'm not gonna bother. Well, I probably should before I plug in a cap I actually care about. I should probably add all of the security precautions in a cap I care before I start on a cap I care about. So fix the issue where it can error from having a blank return on the power supply, which we haven't seen yet. I'm guessing that was some kind of other error. That was like one-off, but, and it's possible, maybe the program should crash. It should be allowed to fail if that happens, because it might only happen during configuration, and I don't know if the power supply will be in an unknown state after that. See, LED test? I mean, I can plug one in there. Let's see, do I have one in this? No, let me grab a LED drawer. Can you read errors from the PSU and DMM if you set PSU to 0 volts? I think I can read the errors. See if there is an error command here. I'm pretty sure you can get it back. I think you have to run it multiple times because it clears out the buffer as you run the error command. Status reporting, accumulated status, that all seems complicated. Hopefully you don't have to do that. So I'm not putting that in. Yeah, it seems complicated. What? Line 1 amp fuse? I don't think that that's even close to being necessary. There's a lot of things where it could be like, oh, maybe you could need it, but I'm gonna just not worry about it. So yeah. It looks like it seems like if you want to read errors, you might have to read a status register and then check data on it, and it's like, power supply has overcurrent protection before it gets to that. Well, the power supply is limited to 10 milliamps right now. So, because I'm not changing the current output on the power supply at all. So it's basically set to current protection at 10 milliamps, which the capacitor should be able to handle. It's getting at a time when the fight between 1 and 2 will choose the victor. Yeah, yeah, let's see. I was going to grab an LED. I mean, I don't really know. We didn't actually run the program with the, like, reform logic in there with the LEDs. I don't think it's going to do much. I think it's just going to run, like, once and then close. So, I'll grab them, but I really am not expecting a whole lot to happen here. So let's grab the other LED drawer. It's got some more interesting ones. Whoops, what did I pull on? Vacuum power cable. Everything else is fine. Stream's still up. Okay. So let's grab a blue LED. Why not? I will pop back over here. Did I quit Vim? Oh, weird. Okay. Vim. Open Reform V2. Set voltage to 1. Vmax to 3. Current really doesn't matter. Since it's limited, it will just be fine. Okay, so we're there. This probably just won't do anything at all, actually. That's my guess. I may also connect this backwards first time. Boom. It just turned on super briefly because, well, why actually? Because it was it 1 micro? That's weird. What? That doesn't make sense. Look at this. So there it is. Boom. One round. Does it not even get to query the multimeter? The multimeter says it's drawn 2.1 milliamps. What gives? Yeah, I don't think this is a valid enough test to be worthwhile. I think just a resistor, if anything. Here's a resistor added in. It's going to be more useful. Yeah, so not a whole lot going on there. Okay. Let's end that. I think, yeah, I can't think of a reason not to try the other ones now. The real capacitors. It's a little scary to think I'm going to actually do it, but I can't think of a reason to not. So, all right. Let's start working towards that. Those capacitors are 3-leg capacitors that are soldered to a board in there. They are not screw lug capacitors, so I'm going to have to remove the power supply board, and then I'm going to have to desolder them from that. So that's a thing. I've already looked at them. I'm pretty sure I know which is the no connect leg, because on a 3-lug capacitor you usually have a positive and negative and a no connect that is just for mechanical stability. And it looks like they actually assembled it in a way that makes sense for mechanical stability, but I'll get into that once it's up here. So, see, I'm so glad it started fresh wool for this 3D print. Did not have to want to try splicing. Yeah. See, right now I'm trying to change the name of a cheap Bluetooth module from eBay, only to find out software only supports their own USB SPI program unless... Yay! That doesn't sound like a whole lot of work at all. I left a bunch of these test clip leads out of here. All right, we are going to kind of do this the way that we were working on the other caps that were fine. We're going to start out with some low voltages and then work our way up. So I'll probably start out at 5 and then 10 as our voltage options. But we're going to go all the way to 50 volts on this power supply because these are 50 volt caps. So here we go. This is something that could potentially be done in circuit as well, but I'm not going to be doing that. So, okay, someone's made a driver. All right, so let's take a look at what we have going on. You know what I just realized? I forgot to post about this stream on Twitter. I'm gonna just do that real quick. Let's see. Yeah, it's your time to get drinks and snacks. Yeah. About to blow up some caps, come watch. Man, you guys are mean. Let's see here. Can I, like, easily copy my Twitch channel URL from somewhere here? Doesn't look like it. I'm gonna have to type it out. Blah. Oh, you know what? I can be super lazy. I can do it on my computer. Just let it upload the pictures. Boom. Alrighty. Come over here. Not there. This. Oh, I just accidentally launched DaVinci Resolve. Great. Oh, man, that sucks, pseudo memes. Ooh. Oh, that's weird. My laptop, it said unsupported GPU when Resolve tried to start. That's a little concerning. Okay. Huh. All right, Twitter there, done. Let's get back to the actual job at hand here. See, oh, thank you, Hellcroft. Forgot about that as well. So water, because I am thirsty, especially after drinking pizza, eating the pizza on stream. That very, very dry pizza. All right, let's take a look at what we have to do to get this board out. So, first thing is, this cable is running over it, but I think we can just unplug the card edge connector here. There we are, and then find out that it's stuck. Ooh. Ah, gross. Is it taped? Oh, it is taped. I'll leave it then. I'll unscrew it from the back of the chassis, because it looks really clean, so I don't want to mess that up. Although I may have to take this out. Actually, those contacts almost look corroded, so that's good to have seen that. Let's see. All right, so let's start on the back first then. Because we're going to have to remove this connector. So back here, we've got 2 Phillips screws. Go ahead and get those out. I'm going to need a smaller bit. Oh yeah, you want to hear something funny? So I've mentioned when I was editing one of the previous streams into an actual video that it took me 11 hours to edit it because there's horrible desync issues between the different camera angles. Turns out that was a known bug in Source Record, the plugin I use to independently record each camera angle, that was fixed 2 weeks after I started streaming, and I had no idea. And I've been using the old version of the plugin this entire time. So this is the first stream running with the updated version of Source Record from like January 14th, although they actually released an update even later. So I have that one installed, but I could have had this been working better the whole time. The label I will probably take a really nice photograph of. It hasn't fully released yet, so I'm not going to peel it off. So, but I will, because yeah, that kind of stuff is really hard to find. So, all right. So the power supply. Oh, this is gonna suck. Ugh, gross. Oh, that is a... Mitz Altair? Well, Fuzzy 2K, that's an interesting one because I just happen to have a big fat stack of magazines. Do you want it to be Byte, or would you rather see the January 1975 issue of Popular Electronics where the Altair was first introduced? Because I have that too. Your call, Fuzzy 2K. Because I can show you Byte, but it's just going to be an ad, because Byte came out after it was released, so they didn't really, like, have a piece on it. It was just, you know, the thing. It was just like, there it is. Popular Electronics? Okay. So, here's what's going on. So, this is really, really annoying. See if this light will actually help. It will. Alright, see those TO2s? Those are bolted through that piece of aluminum to the circuit board down there. So, every single one of those are going to have 2 screws that have to be removed. And the board itself is screwed with nuts on the outside, and then what looks like a threaded spacer that goes through to that. TO3? Okay. Yeah, that's right. So there's so many that have to be removed to get that board out. Oh, man, that's gross. Also, that's really cool. CompuPro made their own power supply for that thing. Wow, I hadn't seen that. That is hilarious. Dang. Props. Yeah, 15,000 UF. Yeah, that one's okay. That one's a good size. That one's high capacity, low voltage because it's only 16 volts. So, Yeah, so that's gonna be a humongous pain. Also, if I, in order to get this board out, to get to the Phillips heads that are on this side, I have to unbolt this aluminum piece, which is an L shape that goes down to the bottom, and the Phillips heads are on the bottom for that thing. So I'm gonna have to flip it over, unscrew this board, and then unscrew all of the fasteners that are on the back of that. So much fun. Oh man, really fancy bending those diode legs. They may have come from the factory like that, but it does seem like they probably did. So okay, let's go get that issue of Popular Electronics and do our bite break here, because that's definitely the one to look at. Kind of surprising no one's actually gone for that yet, but now I think about it, I have called it a bite break, so it would make sense no one would think about that. But I didn't show it in my video on bite, so it could have been an option. See, light table that PCB when you get it out. I don't think it's gonna be necessary. It's single-sided as well, so you just take a picture of the backside. You got it. I got a whole stack of magazines over here that are specifically related to the S100 stuff in one way or another. So I had this one ready to go. But all right, here we are. This is probably the most valuable magazine out of the entirety of my collection. Give me one moment here because my camera is trying to be a total pain. What's going on? Why are you doing this? That's the better fan. If you were here earlier, you would have seen the one that's in the Shugart drive set I have. That one has no shroud at all. Okay, this thing's really bugging me here. This may work, or it may rotate immediately. I don't know. Okay. Okay, so this is Popular Electronics, January 1975. Oh, wait, hold on. 5-minute timer.
All right, 5 minutes. Starting now.
So for Fuzzy 2K, this is Popular Electronics, January 1975. Yeah, a whole 75 cents. You could almost multiply that by... well, you can multiply that by 100, and this would still be... That wouldn't be enough to buy one of these today. This is the first issue of any magazine that covers the MITS Altair 8800. And the backstory is that this is serial number 1 that was sent to Popular Electronics to do this piece on. And after this, it disappeared and was never found again. So there's the kind of, you know, historical secrecy about this issue. But it is the main piece in this magazine. And this issue directly led to the creation of Byte magazine, after so many people were interested in this, and they were contacting 73, which was the other magazine that Carl Helmers was managing at the time. But yeah, so here we go. The MITS Altair 8800, which really confusingly, I don't actually know what the connection is here, but right down here, they say it is it made possible by the Popular Electronics / MITS Altair 8800, which is a little weird. Popular Electronics is like taking some credit here. I don't think they had anything to do with the design of this thing, but they kind of make it seem like they did. I don't really know. But let's go ahead and take a look at the specs. Here we have an 8-bit processor. Let me turn the slide off. I think that might help here. 6,500 words of memory. I really hate the definition of words, and I will disagree with anyone who tries to argue otherwise. Instruction cycle time. Now that's pretty cool. They measure the length of time that instructions take. Wow. That's hilarious. Inputs and outputs, 256. That's not really helpful. That doesn't mean a whole lot there. I thought what happened was that the first one went missing and the one on the cover was cobbled together the last minute. Then again, I read about that when I was 12, might have misremembered. I don't know. It's all hearsay at this point, so it doesn't really have any true bearing on anything. Number of basic machine instructions, 78. Well, that'll just depend on the processor, which I believe is an Intel 8080 in this, despite being called an 8800. Interrupt. Number of subroutine levels, 65,000. That is a really arbitrary number, not like 65,535. Kind of weird. Also, kind of the same thing with max memory. I wonder if the 8080 reserves space for stuff. Huh. Number of auxiliary registers, 8 plus stack pointer, program counter, yada yada. Then we have 8 interrupts. Memory type, dynamic or static RAM, ROM, and PROM. Memory access time, 850 nanoseconds. Wow, that is slow. For reference, I have like a Voodoo 2 that has special 16 nanosecond access time RAM on it, and I think the normal is about 20. Yeah, or it's actually 12 and the normal is 16, and something like that. But yeah, that is really, really slow. Whoa. Oh, man. Now that's for static RAM, and either half that or quarter that for dynamic RAM. But wow, that is hilarious. So the construction of it has actually gone through the basic architecture here. And you can see that's really interesting. They specifically mentioned that it does decimal arithmetic there because floating point stuff was still really complicated at this time and required dedicated hardware. Another thing here, I don't know how much. Oh, there's the parts list you want to build in Altair. There you go. That's all you need. Let's see, IC1, 8080 Central Processing Unit, IC Intel. Oh, that's great. But yeah, let's see. Oh man, the front panel is a nightmare on there. No wonder MSI was all over saying you just plug it in. Like seriously, the MSI front panel is way more simple. But I was curious here because the S100 bus was not called the S100 bus at this time. They called it the Altair bus. And it was really more so just a 100 pin interface card or connector that they happen to have that they mapped out all the pins on. So third-party peripherals, good grief, at this time would call it the Altair bus. And it wasn't until the next year in, actually it might have been, was it November 75? I have the issue over there. There's a Kremenko ad at the beginning of one of, you know, I'll just go grab it. Why not? I'll just flush out the story here. It is November 76, so it took them over a whole year to come up with the term S100, and the first time it appears is in this Kremenko ad right there. That is the first time that any of this stuff was called S100 in print media. And Kremenko was trying to standardize this as the name. And it's really funny because also if we flip through the back here, I can find you an example of, oh, there's Parasitic Engineering, which is one of the companies that created third-party Altair 8800 parts. And they called the companies that did that parasites. So this company renamed from, I forget what it was before, to Parasitic Engineering just to spite MITS. So that was great. But in this same issue, I believe there is a really nice big, there's an MSI ad on all their stuff. There's a really huge advertisement. Somewhere, there we go, that calls it the Altair bus. So again, it wasn't standardized to S100 at this time like that. So they were calling it the Altair bus colloquially because that's what it was known as at that time. So, yeah. The parasitic engineering embracing the trolls is basically exactly what I said in the video, that was some top tier 70s computer trolling. But yeah, that one is seriously, all this in the popular electronic stuff is a phenomenal resource for this era. There is so much in the video that I'm going to be covering, and yeah, I'm so glad I was able to pick these up to do that kind of thing in person. It's just crazy. So yeah, I'm having a little bit too much fun with all of that. And see, yeah, Fuzzy 2K, Vintage Apple has Byte magazine scans, and there is, I think it's like Electronics World or something. There is a website out there that has scans of almost every issue of Popular Electronics, but they're not all done. But you can find them out there. So I don't need to scan what I have. My collection of Popular Electronics is very incomplete. It just covers the stuff that is, have you ever heard of Ohio Scientific? If you'd asked me that like 5 seconds ago, I could have shown you an ad for that in that Byte magazine, but yes, I have. I don't have any of them because this stuff's all really hard to get, but apparently I'm going to be getting some of this stuff eventually. So yes, I have heard of OSI, and I'm going to be keeping an eye out for like a Sol system, because that would be amazing to get. Ultra Minimalist, thank you for the Prime sub. Okay, let's go ahead and rip open this power supply, because yeah, there's a lot of things I got to take off to get to that. Ugh, gross. That sucks. So, all right. Oh man. Only 4 screws to start. That makes it seem nice and easy. Should start with the bottom ones, and I'm gonna want to do this. Yeah, I'm working on a homebrew that's basically a very enhanced OSI 300. Ooh, that's fancy. Just got some schematic, not even done yet. So I don't, are these nuts captive? I think they are press fit in, so I don't have to worry too much about this. So I just have to keep track of the bolts and the washers. See, good luck with a Sol. I had to persuade the person who originally bought it for 6 months to get him to part with it. Whoa. I mean, I'm not on the lookout for one. It's just, honestly, at this point, I assume I'm going to end up with more stuff than I ever thought was possible. So, yeah. Are you sure you can't just remove the nuts from the top of the board? Well, these ones are... The thing is I could on the ones that are connected to the TO3 transistors or voltage regulators or whatever those are. And I could on the other ones, but there's so many of them, and I don't have... I think it's just not worth it. I think that's what it comes down to. We'll take a look once we get this separated. So I'm going to have to... Oh, great. Heavy power support transformer. There we are. I just don't know that it's worth trying to do that when I pretty much have to do this no matter what. I'm going to give you guys a better view of this than I can see right now by just turning the camera around. So that's what's going on over there. You know what? I can just walk over here. That would make my life easier. So I need to disconnect. These would be really handy, and I could unplug the connectors going to the floppy drives. Yeah, let me take pictures of all that so I don't forget where stuff goes. So, boom, boom, boom. I think it would be literally impossible for me to screw any of that up because I bet these are keyed and this is AC, so either way they go, it doesn't matter, but I want to return it to stock. So I will just, that's heavy and off balance, okay. Caught it before it could do any damage. There we are. And that's the power supply separate. Excellent. Now I can just take this whole thing. Oh, man. Oh, it's so much lighter now. Let's see. Found popular electronics. Ah, there we go. Rolled. Yeah, that looks right. I think that's where I got them from. Let's see. Actually, don't get the joke. The official S100 spec. The way the connectors were chosen by way of, they were on sale real cheap. Yeah, that was what I heard. Camera is coming loose from its screw again. I'm tightening this the wrong way. There we go. When I eventually replace this with another Blackmagic Pocket Cinema Camera 4K, my plan is to use a VESA arm and then move it up and down, and then have the gas strut move the camera up and down. But I haven't decided the last bit that connects the camera. I'm thinking I might connect like a tripod head or something to it, which is going to be a little weird to deal with, but I think it'll be the easiest way to go about it. See, 99 problems since they're all cameras. Yeah, really. So this is what we need to get to. So here's what I was saying. The TO3s are there. But I don't know if these in between are threaded or not. So that's where it gets complicated. I may have a nut driver of the correct size. Let me see if I do. If so, I will attempt to just take the nuts off, because that would be easier in the long run, but I don't know. That's actually perfect. Let's try that. Benefit of getting like weird automotive tool sets is that old computers that use that kind of stuff, it makes it really easy to work on. Okay, so that's that. All right. Oh, there's a bunch of these I got to get off. Because people like my life hacks here. I'm using a pill case, like a 2-week pill case here, to organize the parts in like layers as I take them off, so that I don't have to try and remember where the screws go. It's just when there's something sufficiently distinct, I create a new layer, and then the parts are all separated like that. Kind of falls apart when you have a layer that's got like a bunch of differently sized screws, but that doesn't happen in the kind of stuff I'm usually working on. That's more like a modern laptop issue. So it works out for me. Wonder when the last thing is, or wonder when the last time this thing was powered up was. I doubt it was right before I bought it. And I don't know when it was taken out of commission. Trying to determine if I'm seeing flux residue or leaking caps. I think it's flux residue. I don't know if you'll be able to see this. It's like a clearly dried fluid on there. Nah, not really. Well, you can almost kind of see it in the reflection over the TO, oh, excuse me, the TO3. Yeah, I don't know. Hopefully it's not a problem. So it might be worth doing a continuity test of the transistor diode once it's out. Maybe? Yeah, we can look at that. Yeah, the transistors are there. Okay, this will be the last one. I think. Why doesn't it want to let go? Oh. Ha! Oh yeah, I got uptime fixed. Also, cap swiggy time? I could. I can just take a picture now, look at filling that in later. I don't really want to do that right now. I'm working on enough other thing at the moment that I don't want to get too far distracted by stuff like that. I don't want this to be a 6-hour stream because I go and document all the things like that. But I'll take some pictures and make sure I get the rough deses. Okay. Anyway, those are transistors, not voltage regulators. Yeah. They're soldered through all the boards, so I'm going to have to desolder those to get this board up. The legs are poking through there. You can see them by the screws, so. Wesley got it. Yeah, they are. Which is impressive in a way, because they had to have some, like, pretty good clearance on that. Looks like there's plastic sockets that they go into, actually. But that means I'm going to have to desolder all of those just to do this. Oh, man. I see why people just YOLO flip the switch. This kind of stuff when they get it, instead of doing this the proper way. I'm going to get to use my solder pult here. You sure it's solder, not a socket? Yeah, because it won't pull up, and here, I'll just grab the Nikon. The macro camera, however you want to think about it. Definitely soldered. So that's pretty bad. And if I look down into the groove here, there won't be enough light. So there's the legs. Pretty sure that's just the metal legs of the transistors going through. No socket. So, yay. Alright, solder pult time. These probably already have really nice lead on them, but yeah. Just go ahead and reflow them so it's all good. And boom. Oh, I totally messed that up. There's one. Oh, it's such a tight fit. It's gonna be a real pain to get off. Like a massive, massive pain. Yep, if I wiggle the board while it's under there, yeah, and there's 6 of them, yeah. Yeah, but if I heat the solder and then get a screwdriver under there and wiggle the board, you can see it does actually come loose. But then it immediately cools back into place. Oh my gosh. I think I might try not adding solder on the next ones. Completely clean tip. Have solder wick? Yes, I really don't like solder wick. There we go, loose. So that side also loose. Okay, let's get the other 4. Ugh. Okay, I'm gonna try no extra solder because I think I flooded a bunch of solder down the legs and then it just kept coming back up. It's probably already the really nice lead stuff, so it doesn't really need it. Alright, I have my longer flat blade over here. Get that down in there. Where'd it go? I don't see it. I'll just use the pokey spudger. Nope. Ugh, a big pain. You're recovering him just like I do. Wonder if anyone uses 2 hands. Well, that's what the rubber thing is for. So you can either do it on the table or your hip. It just makes it so much easier and quicker. Ah, found the longer flat blade. There we go. Okay. Try and break these loose. Okay, that one's loose. That one's good. Whoa. A lot of movement on that one. Didn't want that much. Okay. How about that one? Okay, those are both good. Theoretically, this should lift off, I think. These are good. Okay. Oh, I just melted something. What did I touch? Doesn't smell good. Hopefully it was hair, not like keyboard or screwdriver or something. Be this plastic thing. Well, poof, but whatever. The wire? This? I don't think so. It was off to the side. It was over here. That was where it smoked. I don't know what I touched, though. I'm guessing hair. Alright, let's work more getting this off. Come on, you're loose. Just let go. Yes! Ugh. So yeah, there's the little plastic guides that the TO3s were in. Sure those are TO3s, not TO2s, with only the two pins there? The third one's probably the case, if I am wrong. Man, they went to town on that solder. Good grief. Okay, so... Oh, that's good at least. The TO3 is the size. Okay. They do have thermal reliefs in the pads here, so this is going to be a giant nightmare to solder at least. So there's the no connect stability pin, and what I was trying to say is that pin is when these capacitors are upright, that's on the top, so it pulls on that pin first before anything, which is the best way to do it because you have the most mechanical stability then. So that's good. I'm going to try and take out the solder on the mechanical pin first. So you notice how the mounting tab is one of the legs? Well, that's on the capacitors you're talking about, right? So let's work on this. Oh, man. So that's what I was scratching up. I'm trying to... So I scratched off some solder mask. That's a little too bad, but not a lot I could do about it. Good grief. That took up a lot of solder there. So I've seen TO3 chips with up to 13 legs. Oh, wow. Notice how mounting tab is one of the legs. Okay, so, oh, in that case, you're talking about the screw lugs. Okay. All right, let's go one more round on these. Try and get the last bit solder off. All right, now for the big ones, I'm just going to go back and forth between these. These are going to have enough thermal mass. They should stay liquid for a bit here. There we go. One down. don't think that leg released correctly. There we go. There. All right. So these are identical, but I will mark them. Have we finally gotten the power supply out? Yes, this is the power supply. I'm removing capacitors now. Let's see, soldering iron suggestion. Yeah, that's not a bad thing to put on there, Wesley. I might do is like iron, but yeah. 1, 1, 2, 2. And we'll do 3, 3, because I want to pull out the other one as well. Ah, really? Stupid tape. All right, so this one went up top. Boom. That one went down below. And the other one will be 3 once I get it off. Oh man, I saw that perfect arrangement of pads or pins there, and I thought it was like a 5-pin capacitor for a second. Oh no, that's gonna be a huge pain to get off. Dude, this camera drives me crazy with the thing loosening all the time. There. Okay. Actually, I think that one was pretty clean. I'm gonna leave that. All right. And work this one out. Perfect. Oh, that's such good smelling vintage solder. Ooh, yeah. That's unrelated coughing. Don't worry about that. Okay. The other nice thing is, since I've already photographed all of that for CapsWiki at some point, I know where these go extra. So, all right. Is it time? Are we going to recap a vintage cap here? Or reform a vintage cap here? Oh boy. Will bit donations help Shelby reach affiliate? Seems like won't. So, Malcolm Chesney, the bit donations just help support me financially. That's it. The ability to do that is a feature of becoming an affiliate. Excuse me. I'm applying for partner right now. Twitch might actually see that because they apparently take a lot of stuff into account when you apply for partner. Twitch might see that as like a benefit that I'm making money on the platform, which the platform does get a cut of. Twitch takes the smallest cut out of bits, so that is something to know. but it's not a direct thing for partner, but they might actually take it into account when they're doing it, just because they have like a lot of weird stuff they do. So, capacitor entered sprayed through the air would complement the rosin well? No. So let's see. See, are you able to check the capacitance in some way before starting? So here's the thing, OLN. Anything I connect to these will probably start to reform them. So I could check the capacitance, but it does that by like charging and discharging them. So if I want the fullest experience, actually, we're going to do a couple of tests here. We might as well check the capacitance. You know what? Let's do it. Because I also want to measure the resistance before starting and then after. So that is, we're going to do a capacitance test and a resistive test. So let's do this for real, science-iness. Let's take some data and actually log this stuff. So let's make a new text file here and record some information. Caplog compu pro disk 1. With bits, the person buying the bits pays the fee. Well, the person buying the bits is ultimately always the one paying the fee. I don't get a fee taken out of what I make, as far as I'm aware. I haven't seen that. So the fee is always on the person who is donating the money. So, difference between screwing around and science is writing it down. Yeah. So, okay. So we have a 1, a 2, and a 3, and I will be doing resistance measurements of all of them. And we'll be doing capacitance measurements as well. So UF, UF, and UF. And I will be shorting them before and after each test just to make sure that everything stays the same. So let's try and do a resistance test first, because the capacitance test may not actually be all that helpful, depending on how far gone they are right now. So, see, 1 bit is 1 cent for the streamer. Yes, yeah. That is what it works out to. Cams. Hiram, thank you for the 500 bits. So, okay, if I put these together, we get 0.15 ohms. You can't see that. Let me arrange this in a way that you can. Ugh. There we are. 1K bit badge. Ah, cool. Okay, so 0.2, all right. Malcolm Chesney, thank you for the 300 bits. That all does really help, and we'll be going right back into production stuff for the streams and videos, so I do appreciate it. All right, here we go, our first measurement of vintage caps. So we are at oh, it is not happy. It is a high value. Or super low. Oh, wait, yeah, super low makes sense, actually. It's probably having a difficult time adjusting quick enough. So 0.5 mega ohms, am I reading? Okay, 0.57 mega ohms, maybe. It's really confusing. Or that'd be 517 kilo ohms, okay. Let's see. Now you can buy Coke, yeah. And it's reformed. Yeah, not quite. Okay, let's do 2. All right, we're doing a second hype train, I guess. Wesley, 4-wire resistance only needed for sub 1 ohm stuff. Yeah. Wesley, thank you for the 100 bits. Fuzzy2K, thank you for the gifted sub. See, please don't get him started again on artificial sweeteners. Okay, so let's go for the next one here. Like 200's changing so fast. Oh, I know why it changes, because it charges. Okay, so 630 kilo ohms. So 630. Light the Unicorn, thank you for the Prime sub. Commander Keen, thank you for the 250 bits. And Light the Unicorn, thank you for the gifted sub. You know what I just realized I didn't do? The Choo Choo. Oh my gosh. Malcolm, thank you for the 500 bits. Okay, so that one was 630. Now let's do 3. And it'll take a moment to charge. There it goes. That one, I got the best connection on, geez. And there we go. Looks like 585. Let's go with that. So 585 kilo ohms. PS Repellent, thank you for the 250 bits. So, okay, those are those measurements. I will now go ahead and short these. The charge is going to be so insignificant on them that just a direct short's not going to be a problem. Hiram, thank you for the 500 bits. Okay, now we're going to try a capacitance measurement. Go ahead and turn that off. We're going to use the... whoa, okay, hold on here. Sagged 20,000. What is that, bro? What are you doing? Okay, I'll get to you in a moment. I'll answer your question. But first, hello, since your first time chatting. Malcolm, thank you for the 5 gifted subs. Sagged. So what I'm doing is I've taken apart the power supply for an old floppy drive, and I'm trying to recondition the capacitors to work correctly in this. But what I'm doing right now is taking measurements before I begin the reconditioning process so that I can know what condition they are in at the moment. So that is what I am doing. So what I'm going to do right now is use a capacitance measurement device, and then I will see what the actual current capacitance of these is. Alrighty, so we need to go to CS, boom, come on, it's not RS. I kind of hate using this thing. It's really complicated and weird to figure out. What's the third leg on the capacitor for? It is for mechanical stability when mounting. There we go. Picofarads? What? That doesn't make sense. Let's see. Can you set it to 60 or 100 hertz? Yeah, I can. Just give me a moment here. Just trying to remember what like the best setting is. I think see there is frequency, but like I should be able to do ESR as well, and I forget how you do that. Is it this button? D, Q, RP. Okay, I think that's ESR. And then frequency, set it to 100 hertz. There we go. Boom. 4,100 megafarads. Actually, I think that's pretty good because it's a 4,700 UF cap. So I think that's right. ESR 0 doesn't make a whole lot of sense. But I think that's right. Unless that's UF, in which case it's very not good. So let me very quickly do 4.16 MF, and then here's what I'm going to do. I'm going to turn it off, and then back on, and it will show what all the units are on the display on the power on self test. So that maybe I think it's MF or microfarad. So actually it's doing really bad. It's at 1/1000th of its capacitance. So yeah, that's not good. Small m, millifarad, about 1,000 UF. Oh, it's millifarad, but I don't see it having a oh, so if it might have a capital M. Okay, let me check. Does it have a capital M? I might. It has a UF. It has a UF. So, all right. By the way, your mouse is on fire? Yeah, I don't think so. So it's okay. So it is UF. All right, got it. If capital M is megafarad, all right. I'm satisfied with that. Seasoned B on actually really old stuff. I have an example of it over here. Where'd it go? Oh, it's way over there. Capital MF used to mean microfarad on like really ancient stuff. So it was actually used. It's just not super common. Commander Keen, thank you for the 5 gifted subs. So that is, I would not have expected to get a hype train and to go through it like that. While we're just measuring some capacitors. But wow. So, all right, let's do capacitor number 2. Okay, frequency is 100 hertz. That's a light. I don't think it'll actually help, not even slightly. I'm gonna set to that. Boom, boom, ESR. So, I don't know why it's ESR 0. I really don't like that. That could be because, well, I really don't know. Maybe the frequency is a little low. So 4.15, all right. So 1 kilohertz is just out of range. 10 kilohertz will be, okay. So it was 4.15 microfarads. 4.15. You said keep up the suspense, Commander Keen. Let's see, peel off that protective layer. I am intentionally leaving it on because I might hit it with a soldering iron at some point or something dumb like that. So I'm leaving it there. So yeah, the capacitance doesn't seem to be all that affected, which I am not particularly surprised by. So, all right, last one, number 3. This one's different. This one is 15,000 UF at 16 volts. And it reads pretty close. 13. Yeah, 13. Hold on, I've been marking this way wrong the whole time. There we go. 560 UF. Okay. So we now have baseline measurements for everything. Yeah, 13,570, 60-ish UF. So there we are. BS Repellent, thank you for the 250 bits. And Valiant Steed, thank you for the 114 bits. You may get ESR reading if you cal on the DE. I'm not really worried about the ESR because it's absolutely irrelevant at this point. So I'm not too concerned about it. But thank you if you for letting me know. Well, you know what? We'll try it on one. Actually, why not? I might as well. I'm just not that worried about it. I don't know if it'll change. So power, frequency, 100, CS, boom. Come on. Cal. Yeah, because it's on, like, auto, it won't let me change it, I think. Okay, ESR. And then I will hit cal, and I don't think it does anything. I don't know what cal does. So, I don't know. On every other capacitor, it's actually giving me an ESR reading. So, whoa. Wesley, thank you for the 55 bits. Light the Unicorn, thank you for the 40 bits. Commander Keen, thank you for the 399 bits. Cal does with open leads, shorted leads. Ah, okay. Cal. Okay. And then Cal. Do I have to, like, go into a menu to do it? Setup. Cal. No, pressing Cal doesn't seem to do anything. I'm just going to not worry about it right now and move on. Because I want to get to the actual reforming. And I don't know quite how long that's going to take. And I want to let it run for the full course of one of these. So however long it's going to take is how long I'm going to be here. So, yeah. Thank you all for the level 4 hype train. You guys are amazing. I really do appreciate all the support, and it does help a lot with doing these streams because the streams are self-sustaining, and being able to spend as much time as I am in them actually makes sense. So I really do appreciate it. See, I think the Trillion Union cal just refers to calories you burn pressing the button over and over again. I do apologize for making you repeatedly say unicorn. Corn, that's no problem. Okay, let's go back to the software, although really quick, I'm just going to short out the pins on all the caps. Probably not going to make a difference, but we'll just do it. Okay. So, like I said, we're going to do this in stages. So I'm going to save and close that for now. I'm going to reopen the software. And the first thing we're going to do here is we're going to change the CSV that we're logging to. So this is going to be, I want to add, actually, I want to add a little bit of code here to the GUI. Let's not, hold on, QA, whatever, close all of it. So, reform -v2. Okay, I'm going to open the GUI and I'm going to have it prepend a timestamp to the log files that it makes. That way, although that's going to be a little weird. Yeah, why not? Because I want it to have a name or a date time there. So log start equals, and then I already have it prepending time automatically to the data. So this, and we'll just save that as a string. Boom. And then file path will be, ooh, that complicates it because I can't just prepend that. Oh, that's right. Dang. All right, pass. You know what? I'll just import date time into the main thing and put it there because, yeah, that's going to be not fun. Paste. No, not that. And then that. Does that have illegal characters in it? It may. How do I just get year? Or not year? I don't know. You know what? I won't worry about it. I'll just undo all of it. It's not necessary. I'll just properly track the logs. Right. Okay. Can quit that. See, could have used a uni number. Okay, log 001 CompuPro disk 1 C1. Okay. Actually, I'll put 001 there. Okay, so we'll save that. You could also, I could do that, Commander Kane. For right now, I'm not going to worry about all that. But I definitely could. All right, maximum current, 10 milliamps. Let's set our Vmax to 5. So we're going to limit it to 5 volts for reforming. For the reforming current, I'm going to limit it to 3 milliamps. And when it gets down below 150 microamps, I want it to step up the voltage. So start at 3 milliamp. You know what? Let's 2 milliamps. It'll jump up to 2 milliamps. When it gets down to 150 microamps, then we stop it, or it bumps up the voltage again. So max 5 volts, 2 milliamp, max current, 220 ohm resistor, 150 microamp step. Right. Okay. I think we're about to reform a capacitor, at least up to 5 volts. But I think we're about to do it. So, you ready to witness the first vintage capacitor reforming on Tech Tangents? Because this is kind of a momentous occasion here for me. I've been trying to work my way to this since 2020. There's that. It can fall on its side. That's fine. What's with the ASCII train? Did it just go by again? Let's do that. Hide that. Okay. Here we go. I'm gonna run it. That is taking a lot longer to settle down the capacitance, the current. Ooh, why is it increasing? I am aborting. In my mind, what was happening is that it was burning a hole through the dielectric there. So here's what I'm thinking. I'm going to set the step to that so it can't get as high. And I'm going to add a secondary thing here. Or let's see, DMM I is less than 2 times d cap I underscore max. So if the current rises above 2 times the maximum that I'm allowing it to, which will go, it'll be going up higher, then it will shut off. So PSA swap to sacrificial test cap after code change. That's the thing, Savic. There is no such thing as a sacrificial test cap. It can't exist because the only caps that I want to do this with are the vintage ones. So, yeah. Python operation precedence has blank go before or? I mean, I think it evaluates this one and then you know what I should do? And. There we go. Problem solved. Because it has to be that too. So if either one of these trips, there we go. Yeah, I really hate the lack of parentheses stuff in this, but I think that'll work. Can you replace any of the vintage caps? Should you damage them? This one's pretty reasonable. I could probably get this one without too much trouble. Matter of fact, I'll just, I'll look it up. So, that's Twitter, but whatever. Let's go DigiKey. This is 4700 UF 50 volt. So what would be the price of a mistake on here? Would it not make sense to run it on a regular cap first? So JJ, the problem is these caps that are, I believe, from 1982 have likely not been powered on in decades, and they will have degraded a certain amount, and that degradation will result in them consuming electricity to refurbish themselves. New capacitors have not degraded, and they will just charge. They won't consume electricity as they rebuild their dielectric material. So a new capacitor can't be used for this. So I actually have to use an old one. And the only ones that I have that are of this vintage are ones that I actually need to work on. So I don't have any kind of like sacrificial caps, unfortunately. So, okay, 4700 UF, 50 volt. I'm going to guess the ESR is like super duper low on this, but let's see, voltage rated, I mean, it's got to be 50. Yeah, because the thing is, I'm pretty sure I could buy a replacement for this without it being too big of an issue. That part I get, but if there really is a really bad flaw somewhere, won't it be a good idea to use a modern one first, knowing full well it won't do anything? Well, so what I have done is I've used some out of a power supply from a computer that I think is from around 2010, based on some date codes I found in there. And it worked fine on that. It runs so quickly because the capacitor, even from a decade ago, is in such good shape that it just works. It doesn't actually do a whole lot. So I have done this on this cap, but yeah. So I wish I had other caps. I've been racking my brain trying to think, what do I have that I care less about than this? But I really don't have anything. So that's massive. There's my TV caps I just replaced. Even those are so new that it won't matter. And the fact that they were, the real thing is that these haven't been powered for decades. The instant you turn something on, it will most likely reform the cap. The problem is if it's been off for so long, the instantaneous full power can cause it to short and burn and then blow up. So that's why I have to slowly raise the power on these to prevent that. So let's see. You know what? Let's see what I can find for Nichicon. Nichicon. Boom. Why do they have so many? What series is this? This is unspecified? That's weird. You're scaring me about recapping my T5200s. It's probably going to be fine. I wouldn't worry too much about it. So that's, what's the pitch on this? It looks like it's about 10 millimeters. Let's see, lead spacing, where is it? 10 millimeter, apply. Okay, that reduced it by 3 to the point where I'm now wondering if maybe it was the other one. Let's try 12.5, see what those are like. Let's go with 5,000 hour. Yeah, well, this is actually 85. Bearing is starting to go bad on the other fan. What was I doing here? Oh, these are 85C, but yeah, I would go higher. So probably something like that, but look at the cost of the $5 capacitor, most likely. To find a true replacement, not super bad. Those snap pins won't fit this PCB. Yeah, that's why I'm trying to find like an actual through hole. It's already set to through hole as the construction type. Mounting type is through hole, not snap in. I don't know why they're showing me all these snap in ones. But yeah, something like that is $497. That, I mean, whatever it is, you know. VRM, $386. Scroll to right on the filter, but they're already, these are all marked as through hole. That's the thing. They're already, oh, wait. Radial snap in. Oh. Okay, package, case. Radial cam. There we go. Only 2. Wow. Oh, because I still have the lead spacing. Clear that. Okay, here we go. Yeah, probably so VR, whatever, in stock. There's very limited stock availability, but looking like $5. So really $5 is not too bad to make a mistake. So I'm satisfied with that. Because again, the ones in like the computers themselves are like $40 each. I'm betting. So yeah, this is not bad. So yeah, let's do this. I added in my safety here. As long as the power supply voltage is less than the voltage max, that's good. And the current is less than 2 times the current max. So in a way, these are the sacrificial caps. Yes, that is why I'm doing the disk drive first. Exactly. The disk drive is also less critical, and I could probably come up with some kind of other power supply for it if I really needed to. Wait, what if the computers themselves are like $40? Wait, what? The capacitors that are in the computers are, there's like 4 of them in the IMSI. Each one of those is about $40 per cap because they're enormous. It's at the point where they're just measuring it in like cups of electrolyte that they have to pour into the capacitor. They're so big. Yeah. So, all right, that's all saved. I am shorting the cap out. Boom. Okay. Power supply is off. Capacitor is reconnected. And I'm going to rerun it. So if you need a current draw for proper testing, couldn't you just put a potentiometer in parallel with the new cap? Yes. It just doesn't do quite what you'd think. So, all right. Here we go. And it immediately failed because is that target voltage at 240? What? Okay. Let's see. I think it's music in my followed channels list. Gogcom is playing Dead Cells. Wonder if this game is about capacitors. I don't think so. Let's see. Why did it... Setting target voltage to that. That's weird. Oh, you know what? It might be because the cap is currently drawing power. 240. All right, I'm gonna try removing. I don't think it's this. Try removing my secondary exit. Yeah, that did it. Okay. Capacitors drawing power. Who knew capacitors be artistic? It's something about this. Cap, IMAX, DMM, I. I think the math is just bad on this first route pass. That's what it is. So, that's... So here's what I'll do. I will take this. I will delete it. And I'm going to put it at the end of the first statement. If break. Runaway current protection. Don't forget the stray and. Yeah, thank you, Lazy Crept. I was going to go get that, but I do appreciate the reminder because I very easily could have forgot that. All right, there we go. Now it'll probably work. Boom. And it failed because it popped up a lot of current. Did it do it like really late though? Oh yeah, Blackhawk, you are right. Because now it's, if it's like that, yeah, okay. And now I think it's going to fail immediately because it drew so much current in the first one. Yeah, what? Crud. Let's do settle equals 5. If settle minus equals 1, else break. Okay, so if it's still settling, waiting for the actual value to kick in, it won't close it for the first 5 measurements so that it should actually get somewhere. There we go. That's working correctly. Okay. Current is going down as it dwells at that voltage, and then it steps up the voltage. Excellent. All right. Alright, current is starting to increase at 3 volts for some reason. I didn't pay attention to where it started last time, and I've been forgetting to rename the log, so now we lost the first log. Great. Yeah, it's fine. I'm not worried about capping the precision on the numbers. Okay, so it looks like it went up and then went back down. See, idea put V max on the top so we know what it's set to. The target voltage is right here, and then the actual power supply voltage is right there. Oh, you want to know what the cutoff point is? Yeah, that's probably a good idea to put up there. I can do that. I can put Vmax and Imax, actually, both in there. Let's see. Cool thought you said curses would blow up earlier. Must have misheard. Curses would blow up. Curses will blow up if I zoom in too far. That's what'll happen. Or if I zoom while it's trying to like read GPIB data, it has to rebuild the thing. And log name. Yeah, the problem is I gotta... Okay. Someone want to look up how to get a file name safe timestamp that I can put into the file name. If you can get that for me, then I will add that to the log name, so it'll create a new log every time I run this. Jimmy James, I'm not sure what you need help with. If you're just trying to look for the commands, then you can run ! command. Also, hello, since your first time chatting. Stack Overflow, thank you. Oh, that's beautiful. I don't know why you need so many different things, but whatever. Time, sure, I'll just grab these. I was cheating, use epoch. I mean, I'd almost do that, but nah. I think this is either going to need to dwell at this voltage for a long time, or I need to increase the current max, although it is actually going down. See, this is where the real reforming is happening now. It's probably actually reforming. All right, question. Going down is very good. Going down is what we want. Does the cap heat up? It's really, there's so little power going into it that it's not going to heat up. That's part of why this has to start low and then go high. Does anyone know if you can edit a Python file while it's running, or is it like Bash where it'll offset the execution point in the script? I think because Python compiles in real time to like an actual C file, it'll probably be fine. But I want to put this in the background and then work on the file. You can safely edit it? Okay, so I'm going to Control Z this. But now it's going to be slightly complicated to get to Vim. I'm not sure how I'm going to kill Vim. You know what? I'll just... Can I like, man FG? How can I go back? There is no manual M tree for FG. That sucks. Reforming caps does take a while, so this will have to run for a long time. For a while. Yes, exactly. So like we can see, it's at 245 here. When it first started settling at the pi voltage there, it was actually at 288. So this is it working. This is it doing exactly what it needs to do. And this is why I want this to be automated, because it's going to sit here for like this for a long time, many minutes or many hours, and then it'll slowly go down, and then the voltage will need to be bumped back up again. So use FG. Ooh, thank you, Shadow Logress, and hello, since it's your first time chatting. That is perfect. FG. Boom. Oh, that's awesome. See, the process of reforming old aluminum electric capacitors, application of rated voltage through a resistor for a period equal to 5 minutes plus 1 minute per month of storage. Yeah, that would be great if I knew month of storage. It's a lot more complicated than that, though, if you want to do it properly. Okay, let's add that file name stuff here. So go up here, import. Oh, I don't actually have OS. Weird. All right. Comma OS, and then we'll add those. Save, and then I will grab that. Yoink. And then I will come over here and add it to this. Plus, and now we're good. So now when I rerun it, it will timestamp properly, although that's minutes. I'm pretty sure I can add %s and be good. And if I remember right, lowercase s is non-zero padded, uppercase is zero padded, so I want uppercase. So yeah, okay. You can also use toggle between current and last job. Ooh, that's nice. There's a lot of cool stuff with FG. Let's see. So you don't actually need those imports for the file name. That won't work. You need the line before the file to get the variable t set. One moment. Oh, yeah, true. Thank you. Good catch. Thank you, Gemand. Control-Shift-V. There we go. Import time is enough? All right, well, oh well. That should work. Okay, now let's... I'm just going to actually close this. I can reopen it later because I'm not doing anything special. Let's check this out. I think it's gone down more. Or were we at 240? I think we were at 240. So it's just kind of going back and forth. The other problem is that I may have the minimum current set so low that it'll never reach that point. I don't think so, but I'm pretty sure. Oh, VI, yeah, let's add that. Yeah, we can add that. Vim, reform. Yeah, we can put those in there. So let's set target. You know what? Let's do a group here. And we'll call the group set points or... trying to think, what was the best way of describing this? Controls. There we go. So I'm going to add cap v max ID, and this will be max voltage. And then we will have maximum current, and that is already at microamps. Imax. Okay. Limit values. You want me to substring the values. That I can do, but it's going to be a little bit more of a pain, and I'll have to work. I will work on that later. So that's something that I can do off stream. Because it's not causing an issue right now, I'm just going to not worry about it. So that should be that, and then I will go update those. It's funny, it's going to have to update those constantly, even though they're never going to change. That'll be cap v underscore max ID with cap v underscore max. And I can actually just look over and I can see that it's currently at 272 microamps while it's going. It's really stable. Why does that look so stable? It's almost like the program's not running in the background. It should be. FG doesn't suspend it, right? Or putting it, Control Z. Oh yeah, cap. Good, or CA. Good catch. And there we go. That should work. If you control Z, it does suspend the script. Oh! Oh, whoa, whoops. Okay. Well, then it hasn't been running. There was no reason to stop it. Oh, that's annoying. That's why it's creeping up. Oh. Okay. That's... alright. I was hoping it would run in the background. Like Headless does. Oops. So this is kind of invalid. Why not just open another terminal tab for Vim? That would make too much sense. Okay, yeah, we should probably do that. Let's go ahead and can this for now. All right, output set to 0. Let's BYOBU. Let's do this. All right, let's run. What is it? Reform dash v2.py. Oh, it did not like any of that. Okay, hold on. Update readout. Key error vmax. Okay, so something it did not like. And now we're at bad. Reset. Boom. Okay, so Vim. Cap imin, cap imax. Oh, it's calc vmax. Ah, okay. So let's do calc vmax, and then down here, where was it? Well, that's fun. I accidentally left that like that. But we'll do there. Wait, no, I need to do this properly. F2, okay, then I can F3, F4. Now I can just do reform dash V2. Boom. Blah. Key error, Vmax, IDs, okay. Better for it to barf debugging than to go, oh no, something went wrong. Yeah. So Vmax ID calc. Okay. Where it's on line 111. It's right there. Okay. Up here. Oh, you know what I didn't do? Right there. Boom. Calc. Right, and now it'll work. Bam. There we go. So now we have our max voltage and our max current listed. Perfect. Also, we can see right here, oh, it's pretty printed the name. That's awful. Blah. But we can see right there the name is like that. Why isn't it ISO 8601? That's horrible. Blah. Also, now that I think about it, there were colons in that name. No, there weren't. Okay. I think I'm going to do this. So, day is 18. I bet lowercase m is this. So we're going to change year, month, day. Boom. And I'm also going to put some dashes in between these because that's illegible. All right, that's ISO 8601 standardized. Oh, yeah, this is nice. I really like this. Ooh, we actually went up in voltage there. So it's now higher than it has ever been. This is really awesome, by the way. This is so cool. Like, I've done this manually. It sucks. It takes forever. You have to babysit it for so long. This is going to be so nice. M, not N. Did I put N? I did put N. Good catch. Thank you. Oh, man, this rocks. So I wonder how long this is going to take. January 84. Do you have a particular page, Lazy Crypt? Because this is the perfect time to do something like that. So, yeah. So just a random idea. What about using Screen or GUI Screeny to let it run in the background? That's what I'm doing right now, Tyler Hoot. I ran it in BYOBU, which is just Tmux. I don't need to run Screen for it as a separate thing. I would rather have it run properly as an ncurses program that takes full precedence. But I can wrap that myself. Let's see, or anything around 15 to 20. Okay, that's an interesting range. But all right, let's take a look at that. So January 1984. That late is not over in my pile, so I can just go find that. Wow, this is awesome. Oh, okay. It's not as bad as I thought. The DMM current is actually wrapping down right there. You can see that A appearing, so it's not going to crash. Well, it wouldn't crash unless it printed something so long that it hit the edge, came all the way down, and then printed to that last character. Because it will crash if you print the bottom right character, because then it will forcibly move the cursor outside of the actual region of the window thing. So, yeah. Ncurses program, explain when you get the chance. Yes, I will. I can go through that. You know, I didn't really go through how the Ncurses code works. I just said, here it is. It's cool. Here's the code if you want to go look at it. But I'll actually explain it for you guys once the bite break's over. So, where are we at? We just crossed 4 hours. All right. I don't know how long I want to let this run because we're starting this kind of late, and I genuinely do not know how long this will take. Yeah, we'll let it run for a bit for sure. So, all right, let me go get January 1984 a bite. Alrighty. So what I'm gonna do is I'm gonna make this slightly bigger. Ah, I killed it. Dang it. Start it again. Ah, that was dumb. I shouldn't have done that. Oh well. Oh, we can see the ISO 8601 file name's good now. It should catch back up pretty quickly. I was gonna say I'm gonna go back to cams, but I'm gonna leave that there so you can actually see it. But I don't know if I can reasonably. Let's do this. You might be able to read the voltages and such. Maybe if I do it this way. That way you can just see what's going on while the byte break's going. See, does it actually need to read the values so often? It could wait like 5 seconds between reading, but the only thing that's going to make a big difference there is how big the log file ends up being. And honestly, since it's just a CSV, it's going to be minuscule, so I'm not that worried about it. I can look. The last log file it generated there was 115K. So I could have been logging that to even on an IBM PC with a single-sided floppy drive. That would have been fine. So, what are we calling the poll on this stream? I think we should probably call it now, because I don't think I'm going to go above 5 volts today, because we're past the 4-hour point. It's going to take a while to do anything from here. So I think the poll should be called for nothing exploded. Just that's what I think. So, okay, maybe we'll see why 1984 won't be like 1984. But alrighty, let me do this. And we're going for page 15 to 20, as far as I remember. So, 5-minute timer.
All right, 5 minutes. Starting now.
This is Byte for 1984, and that is just a phenomenal cover. That is really, really great. But we're going just barely into this, really. Like, for a Byte magazine, We are not going very far in at all. We're going for this. Okay, I guess we're just looking at some random ads here, it seems like. Nothing that seems to be consistent between 15 and 20. So, we have a video term, best-selling 80 column card for the Apple II, and then we have some other stuff. You can switch between Spanish characters, French characters, video switch to switch between 40 and 80 columns. That's kind of cool. A switch plate that allows you to just do some manual switching on the back of the card. That's kind of hilarious. So, oh man, that's hilarious. Let's see. Let's continue on. 25 megabytes the hard way. 25 megabytes the Rana way. Oh, yeah. So that's... Okay. That's... What? What? They're trying to say a bunch of actual hard drives stacked together are not as good as some floppy disks? Seriously? Come on. No. No, 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 no. No. We have... see some letters to the editor. Those are usually megabit. Oh yeah, megabit. It's the same thing though, but hard drive's definitely going to be better. Oh my gosh, that's a pretty whatever that thing's. 2.5 megabyte mini floppy drive. That is weird looking. I really like it. What? So that's what it is. Oh, oh, that's hilarious. That's Rana. Okay. Huh. Okay, 2.5 megabytes on a single diskette. Are they weird discs? Or... Huh. Okay, and a box of discs. Well, it doesn't say if they're bespoke, I'm guessing, since that image has their label on the disc, but that's really weird. See, where's Foon? Yeah, really? I should ping Foon. Oh, quad board by Quadrum. You can get this as a quapple now. If you follow Tube Time on Twitter, you might be familiar with that. But that's cool. I actually have the Diamond Trackstar E that can do the same thing. All right. Board waiting. Here's a board you've been waiting for. Oh, S100 hard disk controller plus cartridge tape controller all in one board. Whoa. So you could add, I actually have a hard drive. 2 of them for the S100 computers. So yeah, we might be looking at something like this actually. Wait, last page said 25. This is 2.5. Oh, that was a stack of 10 discs. So let's see. Clio mainframe, that just synchronous protocol. Okay, so that's just serial cards. Ooh, that's cool. 3 ways to speed up your Apple II for $300. Alrighty. Interesting. Satisfying more than 135,000 Apple users. Huh. That's a pet, though. Oh, wait, no, that's an Apple computer on that weird plastic thing that wraps around the Apple II. Okay. Ooh. Now, man, if that doesn't... I want a Knight Rider 5150. I want it to look like that. That's awesome. That's hilarious. I will appreciate any printer that advertises itself with speed, class, and style. That is really cool. Oh, man. More 5150 stuff. This is 84, man. This is, yeah, they're going to town on this. 3 Winchester internal hard disk systems. That's the wrong kind of disk. We got one that's really... Oh, that's BYOH, bring your own hard drive. It looks like it mounts to the board there, and then it has an IDE connector right there. Or it's probably... Is that SCSI? What? SA... It kind of... It's the weird... PS2 hard drive that kind of like predates SCSI. Oh, okay. Whoa, greesh. That always gets me. And we'll end on this just incredible Maxell ad. Wow. That rocks. Sorry, this may not have been really well angled for the camera here because I'm trying not to bump the dut. But yeah, well, always a good trip into Byte. So let's see. See, we just rediscover some obscure forgotten media? Yeah, that's pretty much how it works. Every time I go into Byte, I see something, I'm like, whoa, that's cool. All right, let's go back to here. Let's see, I suppose for the cap reforming, it would be advisable to code it where it puts the cap under load for a certain amount of time and bump up the voltage until the limit rather than doing it manually. Let's see, don't forget to tweet that floppy to Foon. Yeah, I probably should. Let's do it now. See what happens. See, where was it? It was a little bit farther back. There we go. Now I get it. Hard as in hard drive. Ha 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 ha. They're so clever. See, it does look like the input voltage has dropped by a bit. The input voltage dropped because I tried to zoom it in while I was switching to that view, and it didn't reset in a way that did what I want. I bet tech hamsters probably know about those weird old storage formats. Yeah. And that's nice to get that Variac. Let's see, I'm writing a tweet now. Oh, you meant tech time traveler. Ah, okay. Wait a minute, how? 2.5 megabit. .5 divided by 8.
2.5 divided by 8 is approximately 0.31.
Isn't that 312 megabytes? Or 312 kilobytes? Isn't that just like a normal floppy disk? Did it say megabyte? Are they wrong? Is that what's going on? .5 megabytes on a single diskette. Okay, so all right, they have that wrong. There we go. And sent. Well, sending, my internet sucks, so it takes a while and doesn't help that I'm streaming. Let's see, first time chatter. Don't get me started on base 2 versus base 10 sizes. Hello, Mega Bobster, since it's your first time chatting. Megabyte, the cursed unit. Alrighty. That was an interesting one for sure. So we bumped up in voltage at all? It really just wants to keep going back and forth with this, doesn't it? Man, it's actually up kind of a lot to 400 microamps. Maybe bytes, yeah. See, do you use Notepad QQ at all? Is that a Linux thing? Because most of the Notepad asterisk stuff is like Linux or Windows. But really, I just use Kate and Vim. Vim for when I'm doing serious work, Kate for when I'm just like jotting something down really quickly and I'm going to be copying and pasting. Yeah, Kate is pretty good. Kate is really honestly quite good, and it's just included with KDE. I don't have any problems with it, I think. There was one, I think it was, oh, what was it? The other, Kwrite. Kwrite sucks, but Kate is fine. You know what I should do? I should I should add a an average to the current, because that's what we're really caring about. I should add like a maybe 100 sample averaged buffer. That's going to take a little bit of work to implement, and I don't really want to get to that right now. I'm just a little weirded out by how it's just sticking around there. So because we're now at the point where this is just going to take time. And we're not really going to do anything. This is the kind of thing where I'm probably going to have this running in the background of other streams now. DMM has been crawling up slowly. Yeah, that's the thing, Midwise. But then it's also crawling back down, because it was up to 450, and now it's back around to 425, and it's just going, and I'm trying to read the tea leaves to figure out if it's going well or not. And I'm also wondering, well, if I just let it run for a couple hours, will it average out to something good? I don't know. It's possible to do something like BRAF so you could see it rise and fall. Yeah, but honestly, having just a single average number would tell me the same thing. That's the thing. When you graph, you're usually just like trying to get a trend line, and if you just average a trend line, then you can compare the real value to that. So Usagi Electric, hi. This is not a data general cap. It is actually a capacitor for a CompuPro disk drive, so S100. But this is in preparation of reforming capacitors for the data generals. So I'm doing, these capacitors are actually, if I go back to the cameras here, these capacitors are pretty meager, just 4700 UF 50 volts, which is kind of a perfect range for doing some test reforming. But yeah, I haven't got into any of the like ridiculously monstrous Sprague caps yet. But also, hello, since it's your first time chatting here. But yeah, I just have like right down there, the CompuPro and the IMSI that I just recently picked up. And I keep saying this, but it keeps being true. It feels weird to say it, but the S100 stuff is actually a lot less rare than the Data General stuff. So I'm working on that first now that I have it, because it's all aged similarly and in similar condition. Well, thank you. And I've heard, I haven't had the opportunity to catch up on your experiences with your Centurion. I just saw the one where you got the test card, which is really phenomenal. That's awesome to get that. Hiram, thank you for the gifted sub. Yeah, I since I moved into the office, since I moved and got the office, I've had barely any time for watching YouTube videos, and streaming has really taken a toll on my schedule. But yeah, I really need to check out your Centurion videos, because you have a very similar experience to what I've got ahead of me here, and I would like to know how that went. But yeah, I figure this is a really good place to start. So that's what I'm doing, and then once I've got this all settled in, I'm going to take this on to the Data General stuff for sure. So I can go back to this. Let's see. Again, it's going a little bananas. Almost completely reverse engineered the... Oh, that's awesome. That is really cool. Yeah, you have a different thing. What is the CPU in the Centurion? Is it something standard, or is it something weird like the bit slice thing going on in the Data Generals? I think I heard that it is like a clone of the Data Generals, but I'm not sure if that was like completely accurate or something. I don't know. So yeah, Wesley, voltage flat, but DMM is trending up. So yeah, that's the thing. We're not changing the voltage unless the current goes down below 150 microamps. So we can see, oh, we put max current, but we didn't put the current flip point. That was the other thing. Okay, so I'm gonna have to add, another value to controls here. And also I can tell there's something going wrong with the way that it calculates the space for the readouts up here. And that it's putting too much of a padding between those two sections. So I'm gonna have to fix that at some point here. Yeah. CPU is 9 levels crazy. It's actually messed up evolution of old Eldorado E200 TTL CPU, but evolved to use AM29 bit slice ALUs on... All right. That sounds a lot like what the Data General has going on. It's kind of a nightmare. Like if I just tap ESD real quick here, I actually have. I can switch over. Data Generals are right there. So if I just quickly make sure I'm totally grounded, pop off the Nova 4 front panel here. It's hard because they have recessed latches. Oh, that's the hard drive, not the Nova. That's the Nova. Boom, boom. Okay. So, which one of these is a CPU card? I think it's this. Yeah, here we go. So, there's the bit sliced CPU on the Nova. They are AM2901s there. So, yeah, that's pretty much exactly the same thing. So that's hilarious. I'm really going to have to watch your videos on that, because that's kind of awesome that they're so similar. But I'm still a ways off on tackling the 4X here. I'm going to start with the Micro Nova. Because it's a lot less daunting. That's getting... I think I'm going to take out the card above that before I push it in the rest of the way. It's kind of rubbing weirdly. But yeah. Let's go back to this. Catching up here. Yeah, very similar to the Centurion. Oh, that's awesome. I'm gonna have to look. Yeah, you can put that link in chat, no problem. In-person collab stream when? There would have to be relocation of someone to somewhere. I don't know where you are, Soggy Electric. I'm in Arizona. But yeah, probably, I don't know if that'll happen anytime soon. Let's see, I have mentioned I have T9900, T100 microcomputer board with microterminal looking to build into a computer from the main board. TMS 900. I'm not sure what you need to do there, Del Morte, but let's see, microterminal I'm looking to build into a computer. Yeah, that's something where you're probably going to need to look up the schematics, and then you'll need to get like a UART chip to interface with the terminal. But the thing is once you have a computer and a terminal and then maybe a disk drive, that's pretty much all it is. Like the schematic of an Apple II, I think even, I was going to say the Apple I, but I'm pretty sure even the Apple II is it's like a terminal connected to a processing card, and then it just has expansion buses for like the monitor and stuff. So, see, south of Dallas, Texas here. We got good friends in Phoenix. Maybe I can double the visit someday. Just let me know when. Well, it's one nice thing about having an office is it makes it really easy to do that kind of stuff. I haven't yet, but totally could. Let's see, I volunteered to relocate to Dallas-Fort Worth. It's awesome. I'm gonna open your link there so I can go back to it later. Oh, that stuff's so pretty. Yeah, so looks like current has crept up even more now. Weird. I don't like that it's going up so much, but it hasn't like really zoomed up like it was before. See, is there someone who sells a backplane for the machine? It's similar to TI-99? I don't know. I'm not familiar with that computer at all, Del Morte, unfortunately, so I really don't have a lot to recommend. In the early 70s, there's a ton of, or late 70s, I should say, there's a ton of weird computers that people were making and selling as like kits and stuff, so it's really hard to say what all is out there and what you might have. So I don't know. Also, hello, Enroya18. Since it's your first time chatting. Let's see. I got a response from Foon about the floppy disks. He said they say interesting. I don't think so. I know IBM made a 2.4 megabyte quad density 5.25 inch disk. Maybe this is a licensed version of that. I'll have to do some research on it. Thanks. So there we go. We stumped Foon with a floppy disk. How about that? That's pretty amazing. Oh man. Let's see. Ooh, you have a Nova 2, Jot. That's awesome. Paper tape drive. Every time I see a picture of a paper tape drive, actually a reel-to-reel is what I really want for the Nova 4. I don't even know if we can use it, but it's just so pretty with the translucent cover and the reels stacked in it. Oh man, it's ridiculous. I've seen some in nearby states and I've been like this close to getting in the car and driving there because dang, it would be amazing. But yeah, the tape drive is cool. I think, trying to remember, if I have a tape controller, a paper tape controller, or if it's a cassette controller for the S100 stuff. I think I have a cassette controller, or interface card, I should say. So, yeah, there's a lot of stuff in those I'm gonna have to go through. Yeah, current keeps creeping up on this. See, See, the tape drive can be interfaced to the 4 if it has a controller. Yeah, I don't have that, unfortunately. I've got 2 hard disk controllers for the 2 different kinds of drives I have in there. I have the 25 megabyte fixed disk, and then I think it's a 6095 removable disk. And I have 2 of those, thankfully. So here's the thing. Let's see. So, like, here's something that's part of why I'm trying to do all of this here. I really wish this camera wasn't so yellow. I have no idea why it decided to be so yellow right now. So the capacitors that I'm reforming right now go to this floppy drive. I kind of covered all this in the middle. This is just the CompuPro floppy drives that are 8-inch discs, but they just end in the standard 50-pin ribbon termination right there. So they're standard 8-inch floppy drives. The Data General 8-inch floppy drives on my Micronova here, I can't get to super easily. There's a bunch of screws on there that you actually have to remove. But there's a circuit board on top of this that runs all the way back. That is the integrated electronics for the floppy drive. It's like an Apple II where they took a bare chassis for a floppy drive and then they made their own interface board. So that cannot be interfaced to a computer. And what I have is one single 8-inch boot disk for that thing. So I've been absolutely terrified of trying to use this on there in case the drive's bad or something. And then I have no way of getting data onto that from a modern PC. So what I'm hoping here is that once this drive is working and I can read and write data to it from a CryoFlux here, which will allow it to have infinite control over the floppy drive, I can image that boot disk first of all, and then I can use the Micronova as the gateway with the hard disk platter packs, which I do have a drive of in each system, and then I can copy data from floppy disk to this over these, which is the most convoluted way of getting data onto a computer, but I think that's my best shot, and it all hinges on getting these 8-inch drives working with the CryoFlux. So that's part of why I'm working so hard on getting this done first. But yeah, so that's the plan. So let's see here. Catch back up. Visual standpoint, tapes are the most interesting storage medium. Yeah, they definitely are. Hello, Joe Fish Vibes, since it's your first time chatting. Let's see. So one primary reason we use a reel-to-reel computer, they just look so cool. Yeah. Yeah, I'm showing the DGs there a little bit. Yeah. See, Nova 2 is really nice. You get a program by front panel. Yeah, I just don't have that on any of that stuff. DG3 was the last thing I could do that. I do have the front panel, but I don't have the computer, and I doubt it's compatible with the Nova 4. So, yeah, I've got my fingers crossed for those Data Generals. It's going to be a long road, but they're going to be amazing to see running, hopefully. Yeah, it's going to be a very long road, because this doesn't seem all that difficult, but those are going to be massively more challenging, so... praying the computer gods you don't have a head crash. Yeah, so one thing, I don't know if I left it loose on that fixed disk. Try and pull it out here for a moment. I suspect if any of these have, you can't see me at all. One moment. Cams C. Okay, so I suspect if either drive on this system has a bootable operating system, it's a 25 megabyte fixed disk, because I mean that's where I would put my operating system. It has one screw here. Okay. So, dang. Well, all right. So there's an aluminum tray on top of this, but then there's a clear tray over, or a clear cover over the hard disks, and let me see if I can bring up a picture of that real quick. Like, why did that go? Oh, because I enabled VJ. You can actually see the disk on that one, thankfully. So if I bring up my data general album here. Your mic's in a little hot, not too bad. It's just slightly. There you go, that should fix it. So, data general, okay. So if I bring up my data general images here, you can actually see, at least, on the fixed disk here, heads haven't crashed. So I'm actually good there, which is really nice. So I know that that one hasn't crashed, which is amazing. I do know, though, you can see this is a bad sector listing there. There are now bad sectors because I have service logs from Data General that show that they've had to map around. Yeah, there are, it might actually be 2 heads on one side. Now you mentioned that, Helencroft. But I bet there's also some underneath, and I can't remember if there are multiple platters, but I don't think there has been a head crash. So, yeah. But I can tell based on that that at least that one hasn't. And the other ones, so I can see the platters in here. Since these are removable, they probably don't have anything super critical. I can look in there. That disc is fine. Ooh, actually here. This one's had a head crash. This one's toast. I did not know that. Well, that sucks. Huh. I'll get a flashlight real quick. I'll be right back. Oh yeah. Wipe the data clean off. You can see that. Come on, get a good angle on that. There's a stripe on that disc. So, yeah, that's not good. That's really, really hard to see. Maybe if I get this light down here. Nothing spit polish can't take out. Yeah, it's a little more than a scratch, actually. It's missing magnetic material. You know, I know how to do this. Here we go. This will show it. I have to manually focus. There it is. There's the head crash. It is a stripe of magnetic material missing from the surface of the disc, I think. So, yeah. That's really unfortunate. Since my whole plan there was to use that to sneaker net stuff over. Critical stuff should be on the fixed platter. Yeah, that looked good. I do have a secret weapon that I don't think I've shown in any videos. Ugh. Ow. I got hit in the head by something, but that's fine. It's just a heavy wooden platter. I have 2 more disc packs in the box. See if this is bad in any way. So here's another one. Let's see. Oh. Okay. Nothing on the bottom side is super easy to see. So that's good. Top side looks good. So that disc is good. So, yes. Additionally, these are just standard control data, hold on here, 848-12 discs. So it would be totally possible to get additional ones of these. I've just never seen them. I've had an eBay search running since I bought these computers. Never seen one. But, okay, at least I have one. That's good. So that's a thing. Didn't know that other one was dead, though. That really sucks. I wonder if it's something where I could map around the bad side. But I don't know. Let's see. Hope the... Ooh, yeah, I hadn't considered that. Depends on the drive. CDC Hawk reads could survive a light crash. Phoenix drives need about 20K of work. Right, sliders. You know, I think you got me wondering here. Was there a record of a head replacement in the documentation? Because, yeah, current is, still creeping up for sure. I don't like that. It shouldn't be creeping up. It should be going down. I think there was a head replacement on one of the drives. I can't remember which one it is. Install new temp compensator PCB, replaced controller PCB, preventative maintenance. Oh, there's so much stuff. In cursive, I hate cursive. Replaced, oh good, in 1986 they replaced the disk filter, so, you know, be no head crashes. I did hear that had happened with yours, so that really sucks. Clean disk heads and rails, changed filter. Yeah. Crash platter shipping spacer. Okay, so nothing else in that one covers it. Let's see. The other thing is I don't know which system it crashed in. So yeah, here's the thing. It is, let's go here. These are Phoenix drives. That's why I'm really concerned about it potentially being one of those that went bad. Because, yeah, but I really think they replaced a head on one of them. Just can't remember. So here they replaced a servo board for one of the drives, I think. Cartridge sensor, replace the servo board again. I have all of these on Caps Wiki, my website for that. All of these service manuals are scanned and on there. So let's see. The drives are probably the hardest part of the entire build. I've got 3 CDC Hawk drives, hoping to get just one of them working right. Wow. For software, we're probably going to have to write new. Yeah. So I'm just hoping the Data General still has Bible OS. Me too. Really badly. And if it does, I have no idea how to back it up. That's going to be like a humongous problem. Because maybe I can do it with the fixed or the removable platter over to the floppy disk, but I have no idea what kinds of controls are. So, oh yeah, Wesley, it is running a bit long here. Let's see. Yeah, this is the other thing. They've replaced the logic board in my Dasher D2 like 3 times. Okay. 6040 intermittent, no problem found. Going to rerun overnight. Tighten caps. Yeah, I love this. Hey, a note that it says they tightened the screws on the capacitors in the 6045 on the this 4X. See, did you show the curses code yet? Oh no, I didn't. Let me look here, finish this, see if I can find a head replacement. Not ready. Screw which actually caused a problem. Ordered plastic guard for fan. Oh, weird. Disc loose ready on 6050. Could not. Would have ordered servo and logic PCB. Oh my gosh. So, all right. I don't think I'm going to find it quickly. I am super concerned about dirty air filter head crashes in this, because these computers came from a small business material production facility where they had so much dust all around the whole thing that Data General actually sent them a specific letter in part of their site inspection before the installation of the computer that it was ridiculously dusty and that it would actually be a problem for the systems. So I'm super hoping that there are no problems with the other drives, but I guess we'll find out once we get there. So yeah, but we'll see. Oh man, let's see. Completely custom instruction set. That custom Centurion programming language assembler was built from. Yeah, so to get a grasp on test operating system on DAG board. Hopefully, you can get that. Yeah, that would be awesome. At least, you know, that's really nice that you can at least dump the test operating system on the DIAG board. I assume it's in ROM, and get an example of what the instructions do there. That's gotta be super handy. So a lot of my issue with the Data General stuff is less that it's been backed up, but more that the backups are being held right now. There's one person who has a lot of Data General stuff, and for better or worse, they're holding on to it partly because they're running a business and they know if they actually just like make all that information public, at least is my understanding, that Dell, the current owner of the Data General stuff, might actually come after them because they do actually run a business off of this. So I don't know. See, is Micronova programmed in assembler? Does it have any higher level languages? See, the thing is I have no idea how the former owner of this used it. Like, I didn't get any software with it as far as I'm aware. I have that one boot disk and then 140 indexed floppy disks of data, I believe. Every single one of them has a number on it, and I'm guessing that they had a book somewhere that corresponds. This customer information is on this disk, but I have no software, so I don't know what they used it for. I'm hoping, I mean, that's another thing, is that once I get it running, I have no idea what I'm going to do with it, but it probably will be assembly, which would just be machine code, and I don't know how I'll get it on there. I think you might be able to put it in through the serial console, so yeah, I don't know. See, it was indeed in ROM. Between that and some really old E200 documentation we found, we got about 200 of the 256 opcodes figured out. That's excellent. That's really awesome. See, poor Smog Nova uses as a mud server. So, all right, somebody wanted to take a look at the curses code, so I will go ahead and do that. Yeah, 400 disks explaining why they're not cleaning up the dust. Yeah. See, since the Nova's an M2901 setup, I'm guessing there's a handful of ROMs of microcode on the CPU board. Those could give some insight in the microarchitecture a bit. There are some Data General branded, actually there's a lot of Data General branded chips on it. I've been told that Data General would actually order enough chips in bulk that they would get them custom branded. So I don't know quite what is like a custom EEPROM and what is just like a rebranded 7400 series logic chip. I found out some of the disk controllers on the Micronova for like the different floppies or the different hard drives, I think. Or maybe it was serial stuff. But anyway, there's one that has like a standard part number on the chip and then another one that has a Data General specific one. So I can see that that is how they operated, and it's just kind of annoying. So, sorry, hijack your stream with mini computer stuff. It's not a problem, Soggy Electric, because I'm at a point now where this is not doing anything because we're just waiting for the number to change. And unfortunately, I'm not liking the way the number's changing. So, yeah. So let's see, somebody wanted to look at the curses code. So let's go ahead and do that. You gonna show off new stuff so we don't mind? Well, I showed off the hard disk platters that are in the boxes. That's pretty much the only thing that's actually new. Everything else I've really shown in the couple of videos. And I might have even hinted at the other disk packs. It's just, mostly that I don't want people thinking that they need to harass me to dump them, because as soon as I can dump them, I'm going to. And I know that they're really hard to dump, so I don't want to try and send them somewhere to have someone else try and figure it out, because it's honestly the best hope for getting those dumped is probably sitting right there. So, all right, let's take a look at the GUI code. So, let's see. Over in the actual GUI file is where all of that resides. And I've actually well commented this out as much as I can. See, this is, people can harass someone, they're going to, exactly, yeah. So, why, oh, I can't scroll anymore because I'm using BYOBU. So, all right. If you're not familiar with curses, curses is a terminal interface wrapping program, and I'm honestly not even sure how it works, because when you write to like a serial terminal, you just have a log of all the data that's sent to it, and if you have something fancy like a Commodore 64 or even my HP80 series stuff does this, you can scroll the buffer of text up and down a little bit. But that's not really how the like TTYs on Linux work, but you can go up, so like I can actually do alt page up or page down, or I can't right here because there's nothing in there. So if I run dmessage, we'll just get a, really, okay, ps aux there. So now there's a lot of junk in the terminal. I can page up and page down through all that stuff, but that's in the history of lines. If I go back to Vim, you'll see that that overwrote the whole screen, but then when I close Vim, it goes away and it didn't disturb all those lines. So Vim is using curses, or N curses now actually, and it's an interface API for the terminal that allows you to have a screen-based way of displaying information, and it doesn't just print to STD in and STD out. And it's really weird the way that it does that. I don't know how it actually does without disturbing the terminal, but that's not a problem for me to figure out. But that's what it does. So I'm using that to display this code because it also makes it easier for you to create a GUI interface that you can update and change things about. So that's really handy. But there's a lot of really annoying boilerplate code that you have to put in. So let's go over how this is done, because it's kind of interesting. So the first thing you do is you initialize your screen, and that will change it over to using the weird buffer. Then you can enable color mode, and the only reason I'm using color mode at all is to do the inverted text headers. On a ye old-fashioned terminal, you would just do a reverse character code, but on this I'm doing that. So see, that behavior is different in a Linux TTY, I believe. The buffer switching stuff for a screen-oriented program only works in an X11 terminal, I think. Well, we can find that out real quick, like. If we go, yeah, this'll work. Oh my gosh. Oh, it's not outputting video because, okay, I went over to TTY2 on my laptop and you can't see it. Pure pixel Vim in 4K is ridiculous. Look at that. That's the pop-up text that shows up in the middle of Vim when you turn it on. That's how big that is. But if I quit Vim here, okay, so it is only X11 terminals. All right, because now all the Vim stuff is still there. If I do ls, you'll see it bumps it up. Okay, so it's only X11 terminals that it works in. That makes more sense. So now we can go back to this. Was that a GUI for ants? Pretty much. That's the downside of 4K, because stuff does not work well. I'm using this as a color pair, which is manually setting a white background and black text instead of just the reverse character. I really wish it would use a reverse character, because I might actually use this with vintage terminals at some point, because that would be fun, but I don't know. Then I declare some boilerplate data management stuff, and then I have some other generic stuff here. Where it gets really interesting is a little bit farther down into the update area. So this is where the actual GUI stuff happens, and everything else is just me managing that in the background to make it easier to use. So on every frame that it draws, see, time to get an old ASR33 and go for the real OG terminal. I was this close to getting an ASR33. It was missing the tape reader, and I don't think it had been used in a really long time. And I think it didn't come on the original stand. But I was so tempted. It was just before I moved and I had nowhere to put it. Right now, in a split second, I would have grabbed it. But yeah, being kind of beat up and missing parts and unknown condition, and yeah, I wasn't sure. But now, totally would have. So I am going to keep an eye out for one of those because that would be awesome. So, okay, starting a new frame, it clears the screen and refreshes. What that refresh here means, actually, I believe, because if we go down all the way to the bottom, we can see a refresh there. What that refresh does is that clears the screen buffer. So if we eliminated this refresh, we would actually end up with like the solitaire like history of where stuff has been. So that one draws blanks, clears the screen. So then we get the size of the terminal every single frame, because I can actually resize this. I can show you how there it can be resized. And it crashed. There's something with the GPIB code where it doesn't like it. I'm actually going to leave it there because we're about to cross over 5 hours, and obviously this is not going anywhere for some reason. So yeah, although I should start it and then kill it so it can turn off the power supply. Or I'll let that run for a little bit while we're going. Why not? But I am wrapping this up here pretty soon. Just to let you know. So we get the size of the terminal, and then we can use that to figure out what the max bounds are. Then you can add strings to the terminal in this is irritating, YX location. So it's the line that you want to print it on, and then the number of characters into that line, which kind of makes sense in vintage terminal land, but for graphic stuff, it feels really weird that it's YX instead of XY. Fuzzy 2K, you gotta go? All right, see you later. See, there's some CRT lurking emulator you can get. Yeah, retro cool term, OLN. See, my SR33 has a harsh slice and it's just seized in a solid brick. Ooh, yeah. Okay. So you can add strings, and I use raw string commands on the base window for screen to set the header. Then I create an object that I'm going to draw all of the little sub windows in, and I start iterating through the readout. So each one of these variables that I'm printing to the screen, I've defined as a readout, and it stores the actual value, a label, and then a group that it is a part of. And if it didn't have this group, then the label here would just be printed up there instead, and it would just be a box with that number. Good night, sleep time for me. All right, Helen Croft, I'll see you later. I am wrapping this up soon. So each readout is an object in the Python code that gets a new window created if it doesn't have one. And then the way this is supposed to work, and it clearly isn't because there's too much space, it's supposed to keep track of how many lines of data are in each window and then save whatever the maximum for all of them is before it prints a new line. And then it's supposed to space out the next line of stuff like that. Let's see. I cannot pronounce your name, but I'm going to try Miss Toolfarer. Is that a library that's available for anything besides Python? Curses is actually C. It's probably even available in assembly. It's ancient. Ncurses is the modern replacement for it that you can use. And yeah, you can use that in C, probably a bunch of different languages. So, yes. You can head out to Season B. All right, I'm losing all my European viewers right now. So anyone else who needs to bow out for sleep, I don't blame you. So I make a new window, and then I start drawing into that. I try and keep track of how tall that window gets, but I'm not doing it correctly. And then I have to check if a new readout, so the way that it works is in the code here, I register readouts with the GUI program, and then it keeps track of those, and if they have the same group, it'll try and add them to the same readout thing. Let's see. Oh, that's End curses, great. I need to have a look at that sometime. I hate Python. It's just I hate Python. Yeah, I don't blame you there. But yeah. So I'm adding these to the group, and then I add a new line to it, and then it adds the window. Well, this gets kind of weird. The way that it works is really annoying. So I add, I keep track of this stuff, and then I draw a border for the window, and then I have to draw the title, and depending on whether or not it's a group and has a separate label, I will draw the title as a string, just a regular string over the border. The titles are not like an included thing. It's dumb in that way. So you just draw over the border to add a title, and then I will add the label and the colon and then the actual value. So all of the readouts are done on a per value session, instance, however you want to think about that, and then they're added to the display one window at a time. Then the table at the bottom is a whole other thing. I'm actually doing this with a backup of the data ideology first. So this GUI is actually doing the data logging for me. You start out by initializing the file with a header line, and then it writes that header to the file. And then you can update the data for the log, and it will write out the next line of the CSV. Got to go to work in 2 hours. Well, Hiram, I am not going to be here in 2 hours. I will be on the floor asleep if I try and go for that long, because I really need to wrap this up. This is a very, very long stream. So you can update the log through the GUI, but then what the GUI does is it basically tails the log file for however many lines it can display on here, and it gets that data, and then it iterates through it, printing out the headers first with the reverse color characters up here, and then through each cell of each line of the data, it prints out everything one at a time until it gets to the end of the lines. And this way this code is actually designed, it can support multiple tables all at once going to different logs, because I've tried to make it as expandable as possible, quickly and very easily. See, I'm so stoked I can catch a stream. I'm procrastinating on working on the next video by watching Tech Changes work on the next video. Yeah, that's very true. That I am, this is feeding into my next video, but it's not my next immediate project. But yeah, it was really cool. So, okay. I love having streams on while I work. Get super lonely otherwise. Yeah, I can definitely understand that. A lot of what I'm doing here isn't like immediately watch interesting, but can be fun to have in the background, and I do get that. So, all right. The voltage. Oh, that's really weird. So every time I've let it run for a while, so that's basically it for the code. Then it prints out all the windows and everything at the end in a controlled manner here. So I cache all the window information and then hold on to it, and then I print it all out at once, and that does the final screen draw. So that's curses in a nutshell. And then you have to end when on the curses, you have to close out everything so it can reset back to normal. And if you don't, that's when I have to run that stty sane or reset command in the terminal to fix everything. But ideally, that doesn't happen. So, yeah. But on here, I'm noticing every time the voltage goes up, the amount of current that it will consume goes up. And when I leave it for a while, then it will not go up as high in voltage next time. So I wonder if these capacitors might actually be bad. This could be a symptom of a bad capacitor. I'm not sure. See, I don't know what you're talking about. Your streams are Twitch goals non-stop interesting. Well, I appreciate that. Let's see. Yeah, I should probably wrap this up here. Yeah. See, the streams every time I've caught one. Well, that's awesome. So you maybe try another one of the caps. If I do, we should try the 16 volt one. I'm really hesitant to do that though, because we're past the 5 hour mark, and I kind of want to be kind of we've done now, because talking this long was very strenuous on the vocal cords. 5-hour TT stream a new record. I've actually passed 5 hours a couple times, unfortunately. I really don't want to, but it has happened a couple of times. I love how I designed the NanWin thing to like be used with the actual Windows logo, but it gets used without that the majority of the time, it seems. UK stream. Thank you, Malcolm, for being here, and I hope you enjoyed it. All right, I'll give the 16-volt cap a small amount of time on there. We'll do that. I'm gonna set the limit to 4 volts. Hold on, reset. Okay, so I'm gonna come over here. 4 volts as the limit. Vmax 4. Glad for the long stream. You start at 3. Whoops. AM for me, so I missed most streams. Oh, okay. Well, yeah, that puts you in an interesting area of the world. Yeah, I have an unusual stream time. I definitely know that. That I try to have evening in Europe and then lunch in the US. All right, so 4 volts. And we will do cap 3 here is the one that I'm doing. So I'll change that. I probably should have used the actual ref deses on the PCB. Oh well. Right, okay. So I'm gonna move over the connectors to that one. And I'm gonna run this for no more than 5 minutes. And we're ending the stream, but I wanna see what it does. All right, here we go. That's on there. Go back to capture and run. And it immediately spiked up to using a ton of current. I'm gonna run it again. We'll probably settle back in. Come on. Wow, it is just taking up oodles of current. Okay, here's what I'm gonna do. I'm gonna change settle to 10 lines. Now let's try it. Was that timing based on YouTube demographics? No, I was just going with afternoon, Europe, lunch, day. Not really based on any kind of timing. Wow, it is, there we go. Now we're in. Okay, should settle down, pulls in the current, reforms, steps up. Okay, current bumps up, pulls down. Excellent. Okay, got another voltage step. Gonna get one more right there. All right, next increase. So there's a DG Nova emulator, I think. There's some kind of Raspberry Pi emulator that's supposed to give you front panel access for some stuff like that. I haven't looked into it, but I think there is. So up to 2 volts. Current is still decreasing consistently as the voltage increases. Which this is expected behavior. All right, getting up to 2.7, 2.9. All right, we're into the realm where the other ones start to fail. This one's struggling to get down low enough. Let's see, it's pretty much what I was expecting. Oh yeah, because cropped, you guys can't. Oh no, I did the thing. I need to stop doing that. All right, let's let it. Yeah, there it caught back up, kind of. Okay, it's pretty much what I was expecting. The other cap was not doing it, at least past a certain point. Yeah. So, okay, it's catching up now. Current's dropping. I'm gonna have to fix that resize bug somehow. That's a problem. Yeah, the other one did get 3.14, but the thing is it shouldn't regress. It shouldn't get, like, worse. But it was. This one seems to have stabilized around 200 microamps. And if it follows the behavior, the other one is going to start to bump up. Cap has started to break down. I'll do that. Might be the case with the other one. Yeah. So now the current is increasing. So I only like 30% understand what the program is doing, but could you set it to pull the last value from the log file so it can resume where it stops when it crashes? If I restart it quick enough, the capacitor is going to be in a similar enough condition that it'll just catch up to where it was. So it doesn't really need to do that. That would be possible, but I would rather start from scratch on it. So, yeah, current is still going up. All right, so something's... Either these caps are all bad, or there's something else going on. Now, I will say, these Nichicon caps from this era are not perfect. There are some of these that are bad in a 5150 power supply I have back there. So, Nichicon 1984... not bulletproof. I don't see any signs of leaking, but they also could have just been used a lot. Like, I got like 300 8-inch floppy disks with all of this, and the majority of them are written. There's only 20 that are sealed in the bin still. So it's possible this floppy drive has a ton of miles on it. I don't know. That these could just, they could be gone. So that's very possible. The other thing I could do is try setting a higher current allowance for this. Let's see, well, the caps did measure weird on the LCR meter as well. Yeah, they had like 0 ESR, which is a little strange. But they're old caps that need reformed, so that kind of makes sense. I really don't like it that the current keeps increasing, though. I would expect it to, like, stabilize, but not continue to increase. It could be something like the leakage current allows it to heat up at a certain point, and then it will heat up more through the leakage, and then draw more current because of it being heated, but we're at such tiny scales that it doesn't really matter. But yeah, it is just going up. So you might find that the Sprague caps are much, much better. Yeah, Sprague stuff I've come across so far been really high quality and generally so good. That's what I'm really hoping, because have you had to buy any new ones yet? Because I'm afraid that they're going to be like $40 each now. And I know there's like at least 2 of them in every single one of those drives in the computers I have. So I'm looking, especially now with the IMSI stuff and the CompuPro, probably looking at like $800 worth of Sprague caps in these things. So I'm a little about that. What does it mean if the current keeps increasing? It means that the current's being consumed somehow. And the only way it can do anything in there, well, there's only 2 things it can do. One, it can convert electrolyte into dielectric on the surface of the aluminum as an oxide. And 2, it can just be waste heat as it tries to flow across the dielectric. So, see, I did replace a lot of the small 100 UF caps on the boards, but honestly, it was so the YouTube commenters wouldn't lynch me. The original Sprague caps are totally fine. So I don't really blame you there. Yeah, people can get kind of overly religious about this stuff. I've actually been kind of hesitant to make a video about the reforming stuff because I know people are going to be irate over me not just replacing stuff like the Sprog caps. But I think I will have to go through and find replacements for every single one of them online and then show how expensive they are and total it for everything to really hit home the point of how unreasonable it would be to do it when they are probably fine. These are not looking to be fine, but they're a much lower end cap, so probably gonna have to replace these, it's looking like. I haven't done too much reforming, but this feels like a fail compared to other things I've done. We might actually go with the CompuPro for the next set, because it has some like big Sprog caps. So if you don't show yourself shorting any with a screwdriver, oh yeah. Let's see, also, if old parts can be saved and reused, they should be. I agree. And it's a little wild how expensive it can get. If you reform them, do that without question. Yeah. Oh, man, you have about 12 CRTs. I'm at a point now where the majority of my late 90s, early 2000s CRTs are starting to fail, and I am so not looking forward to that because they have dozens of tiny caps in them that maybe... I wouldn't be surprised if a couple of them even have over 100 of them in there. They're like old receivers that are like the 1,000 watt Pioneers that have just ridiculous numbers of capacitors in them because they do all sorts of digital filtering and manipulation on the image, and they have like analog circuits that does that stuff. There's a ridiculous amount of caps. So, oh man, yeah, not fun. If someone wants to give me 60 CRTs, so I'm trying to clear up space, oh, good luck. I wish you all the best. I mean, I would be dumb enough to take them too, but yeah. So yeah, this cap keeps just going up in current. I am probably gonna do some more research after this. I'm being very conservative with my microamps level reforming, I think. So, yeah, let's see. Speaking of CRTs, do you have a video on cataracts repair? Recently got my hands on old ADM 3A. Awesome. And it's got the cataracts bad. That's new territory for me. I have not done a cataract repair. There are a lot of vintage television channels that do that. Basically what it comes down to is there's a piece of glass on the front that is glued on, and you have to like use a wire to get in there and scrape off the glue to break the seal holding the glass piece on, and then you have to lift the glass off. It gets real scary because I think you might even have to remove the compression band on it. I'm not looking forward to the first time I encounter one like that. So I do wish you good luck on that. I've not done it, but I would look up some television repair channels, like the old, oh my gosh, name is slipping me right now, Predicta, that kind of thing. Those have that kind of problem. So, but Usagi, have you done capacitor reforming, and what current limit do you put on there? Like how much current do you have as your like upper limit on the reforming? Because I'm curious. I found a Department of Defense sheet that has 10 milliamps as their recommended saturation current for doing reforming for radial caps, and that seems a little high for me. So I've been trying to keep it below like 2 milliamps, and then once it's down, I haven't picked like an actual value yet, but I'm thinking maybe 200 microamps, I might bump up to the 2 milliamp again so that it can keep going. But yeah, whole procedure sounds terrifying. But I guess if it explodes to me, that'll make for some interesting videos. Yeah, I wouldn't want to have to replace an ADM 3A tube. That does not sound fun. But it might be like a standard 10-inch or 12-inch monochrome tube. I don't know. That might not be too hard to get a hold of. I haven't looked into it. See, they can implode when you tube them too, so yeah, be careful. The front glass also helps protect you from that. Yeah, well, it's more what the compression band I think is for, because of the vacuum and stuff. It adds like force to it. Yeah, not fun. So yeah, I've definitely let this one go for longer than I said I was going to. Yeah, I'm gonna have to do some more research on reforming. I might be overly conservative on my values here. Let's see, I have not done any reforming. My usual reforming procedure is send it. Okay, I don't blame you there. I'm being really obsessive with this stuff. So with the older HP gear I work on, I replace Bumblebee check black beauty caps with wax paper caps on site. Everything else so far has generally been solid. Interesting. All right. I probably could have just flipped the switch on most of this stuff, especially this. I mean, I could still put this back together and flip the switch, just see what happens. I figured this would be a good test for this, though, but yeah. I think I'm going to do some more research on reforming, see what people use as their values for stuff, and, try and adjust what I'm using or doing to that. Because I'm thinking I might be going a little low. Because that's the other thing. If it's not going to get down to the level that I think it will just sit there and probably heat up as it's connected to power. It'll probably tap out at a certain point. But I think I need to research this a bit. So, see, yeah, but I should actually end this here. I admire the work you're putting into this, so it's going to be super to reform them rather than replace them. Yeah, definitely. And I really want to document the process and explain it to people, because like people will say, oh, you should put it on a Variac and turn it up. You really can't do that on anything with a switch mode power supply. So, yeah. On the Centurion power supply, powered it up with about 5 cards in the back plane to load it down and check the ripple supply with the scope. It's less than 50 millivolts. So I just figured the caps are good. Yeah, especially if you did it with a low load first. That'll do it as well. 5 non-critical cards. Yeah, if you did it with a lesser load first, that's not as bad. I'm very concerned about the S100 stuff, because the S100 bus is kind of ridiculously designed. It has, I think it's 8 volts and like 14 volts or 16 volts, I don't remember, something weird like that as the rails, and then cards are supposed to have their own regulators on them for 5 volts and 12 volts. So there are literally going to be however many cards, X number of power supplies plus 2 more, so it's going to be crazy. So yeah, but I think this is it for now for the reforming. I think the reforming software is done. We're good to go. I just need to tweak the values that I'm using. So yeah, once the stream's over, you get some rest. Still looking forward to an email from you. Yeah, Starhawk, I meant to do it, but this stuff, it took me so much longer to write that GUI than I thought, and then I had to just fly this morning because I was trying to get some other stuff done. So I haven't had time. My apologies. Yeah. Each card has its own 7805 and 7820. The SWT PCs did that too. Yeah, it's a whole lot of fun. Thankfully, I've got a rail back here just full of 79 and 7805s. So if those are bad, I can just swap them. Test. So yeah, my microphones say this has been going for too long, the battery died. I gotta end this. It's yeah. Way too long of a stream. Oh man, that's hilarious. Thanks so much for the stream. If you ever need someone to bounce my mini computer stuff off, hit me up. I absolutely will. Yeah, but this was really great. I'm extremely happy with how well this turned out. I'm really looking forward to playing around with this more. I'm probably going to do it off stream a bit from here. I might run some reforming in the background as we do some other projects, but from here I think the software is ready to go, and I just need to do some, let me allow that there, tweaking with the values. But yeah, I think this is going to be good. And I can start to document this process more for actually making videos. So yeah, I am looking forward to this. It's really nice finally have this done. It seems like everything is good to go in there, that I'm monitoring everything I need to. So yeah, it's just check out the values and plug them in if this is good. I'll have to test it on like a more likely to work capacitor, one of the Sprogs. So yeah. See, that's nice. Oh man. But yeah, so battery upgrade for the mic. No, the mics are a really good size right now. I don't want to modify them. But yeah, that's it. So I think I'm gonna run the wrap up here. That shouldn't be playing yet. Whoops. This was, thank you. I will drive safe. This was a really good stream. I'm quite happy with how this turned out, and I look forward to getting this worked out more in the future and settling into a routine for reforming capacitors, because I am definitely equipped to do that now, I feel. Just have to get some good examples to work with so I can get a feel for the process, and maybe these Nichicon ones here still can be saved. I just got to figure out if maybe I need to bump up the current going into them a little bit to push past where they're at. But yeah, I'm quite happy with this. I hope you guys had fun. If you enjoyed this, you might want to follow me on Twitch, and if you're watching the YouTube video, you can subscribe there to see more of these stream recordings. But that is it for the moment. If you want to support the channel, I am on Patreon. You can also do Prime subs on Twitch. That is it for the moment, and I will see you next time.